Hello, hello. वीडियो ना.
I am online and I can hear you.
Thank you, ma'am.
But I'm not sure of the
Okay.
Once again, I welcome you all. We will resume with our technical sessions. So we will start our technical session 3. For this technical session, our chairs will be Dr. M.A. Paul and Dr. Shalin Jansar will be our co-chair. It's our privilege to have Dr. M.A. Paul, Associate Director, Respond and Academy Interaction Program, Capacity Building and Public Outreach, ISRO Headquarters, with us as our chair for this technical session. Sir, please come. Please take your seat. And our co-chair for this session is Dr. Shailen Jain, Professor in Electrical Engineering Department and Dean Student Welfare, Manit Bhopal. We are grateful and delighted, sir, to have both of you with us. Now, we will be starting with our technical session. Our first presentation for this session will be from Sri R. Sandhanam, Deputy Director of ISRO Propulsion Complex in Mahendragiri, Tamil Nadu. He is also the Joint Management Committee member of STIC Manipal. We request you, sir, please come forward and share your knowledge related to IPRC research areas.
So good afternoon to everybody for the third technical session. So before we start, I will just to inform you that the research areas in space document what we released just now has already been uploaded in our website. So it is a, you know that it's a biennial publication. So next issue will be coming in 2027 only. 2027 only. So now this is the right time to pick up the interest of your topic and submit the proposal as early as possible. Otherwise, someone else will pick up. If you look for that one after 6 months or 7 months, some of your interest, somebody would have taken already. So this is an information for you. And we have got seven or eight presentations. So one more presentation is likely to come. 8 presentations. So I request all the speakers to restrict their presentation to 12 minutes, so that I think we can. It is not correct from my part, but I know somehow we'll have to restrict the time. So, sir, if you please try to restrict in 12 minutes, sir. Thank you.
Okay, thank you. Good afternoon, one and all. So I will be representing ISRO Propulsion Complex, Mahendragiri. Actually, my presentation has 2 parts. The first part, I wanted to explain in a little bit of detail what we are doing in Mahendragiri for ISRO's overall program. But given the shortage of time, that part I will try to make it a little shorter. And in the second part, I will be covering the current ongoing R&D activities and some hints about the future requirements from IPRC. Yeah. So morning, I think there was a presentation by LPSC team. So together with LPSC, IPRC is basically responsible for development, realization, and delivery of all liquid propulsion systems for both launch vehicles as well as satellites. And we are located, Mahendragiri is located on the southern end of the peninsular India, very close to Kanyakumari. So I request all of you, whenever there is a possibility, you can come and visit Mahendragiri and see enormous facilities which are operational there. And regarding the role of ISRO Propulsion Complex in ISRO scheme of things, basically we are carrying out the assembly and integration of all the propulsion systems, like the car has an internal combustion engine. The rocket engine is the power plant for the rocket, for driving the rocket. So we have the facilities for complete assembly of all the propulsion systems, including the complete stages, the rocket engines, and that is done not only for the flight vehicles, that's also done for the developmental testing part. And we have massive test facilities where we carry out all the developmental test and acceptance testing of rocket propulsion engines as well as complete stages. We also have testing facilities for the spacecraft engines, and we have major production facilities for cryogenic propellants. You know, the cryogenic rocket engine uses liquid hydrogen as the fuel, and it is stored at extremely low temperature, around 20 Kelvin absolute, or minus 253 degrees centigrade. We have the production facilities for liquid hydrogen within our complex. Okay, this shows the range of engines which we integrate. And when we talk about integration of one engine, for rocket propulsion, it may involve something like 300 to 400 components minimum. All those things are put together to make one complete rocket engine. And we have the cryogenic engines and the non-cryogenic engines. And the last 2 ones, that 200-ton semi-cryogenic engine is under development, and it will go for testing by the end of this year. And the last one, LOX methane engine, which will be utilizing liquid methane as the fuel. That is still under drawing board, and it will only the subsystem development as only has been initiated. And these are all the various liquid propulsion stages which are integrated at Mahendragiri and which go to different launch vehicles like PSLV, GSLV and LVM-3, including Gaganyaan flights. All this integration is done at Mahendragiri. And we have a wide range of facilities where all these rocket engines as well as the complete integrated stages. When we talk about a stage, it includes the fuel tank, the oxidizer tank, all the gas bottles, the connecting plumbing, sensors, all the harnessing, everything is included in that. So we have this kind of very massive test facilities created with thousands of crores of investment, where we can carry out the complete actual hot firing test of the total rocket system for the flight duration and even beyond. Many engines are tested for something like 700 to 800 seconds. All these facilities are already operational. The semi-cryo integrated test stand at the bottom, that is the one which was recently commissioned and dedicated to the nation by the Prime Minister. There we are carrying out the testing of the 200-ton semi-cryogenic engine. And these are all further test facilities for scramjet propulsion, umbilical testing, and for the Gaganyaan service module and some other related tests. And these are the cryogenic test facilities. We have some unique test facilities like that thrust chamber test facility shown at the bottom. There we can supply cryogenic propellants of liquid hydrogen and liquid oxygen at pressures up to 200 bar, so that you can test the combustion chamber alone without the turbo pumps. Turbo pumps are part of the flight engine. Without the engine, you can test the combustion chamber alone by directly supplying propellants from the facility at very high pressure. In fact, in the whole world, there are some 2 to 3 facilities only of this category. So such unique facilities are available. And we also have extensive SR and safety facilities, including that linear accelerator, which is a very highly powerful X-ray system, which can X-ray up to 200 mm wall thickness. Stainless steel material up to 200 mm wall thickness can be X-rayed with that linear accelerator. And we have like a human body scanning with CT scan. We have computer tomography systems for internal inspection and cross-section generation. And we also have very extensive automation and instrumentation facilities for measurement of pressure, temperature, vibration, speed, a lot of data acquisition systems, and PLC-based control systems and emergency shutdown systems for conducting various hot tests. And coming back to these R&D activities, R&D activities in Mahendragiri, basically that falls into 3 categories. There are one group of activities where the IPRC engineers have initiated the project and they play the lead role and they take it forward. And the second group is where PSSC or LPSC would have initiated the proposal, but the testing for that is done at IPRC, because the test facilities are available at IPRC. We'll be supporting with the testing alone. And the third category is where IPRC will partner with academic institutions like IIT or NITs, and also a lot of CSIR labs also we are partnering for many activities. So this in situ propellant production for interplanetary mission, this is one ongoing project throughout the world, I will say. For example, if we humans are going to Mars, for going to Mars, you have to carry the fuel. There is no other option. But for your further onward journey from Mars and beyond, or for return journey, if you can make the propellant in situ with locally available materials in Mars, then your onward journey rocket mass will come down substantially. So this is something which worldwide people are attempting. And in IPRC, there is one specific project going on. In the Martian atmosphere, we have more than 90% carbon dioxide. If we can make the carbon dioxide react with hydrogen gas and generate methane gas, methane can be used as a fuel for your return journey or onward journey. This is a kind of idea. So a small kind of area, but there are different challenges. The Martian atmospheric pressure is extremely low, maybe 1% of Earth's atmospheric pressure, and we have extremely low temperature also. So in that condition, you must be able to harness the CO2 from the atmosphere, carbon dioxide, add hydrogen to it, make the reaction happen and generate methane gas and use it. And this is one specific problem which we are attempting, but there are many other dimensions of this problem which others can take up. For example, to synthesize methane gas from CO2, we need hydrogen, right? Either I have to carry hydrogen from ground, which is not a good option. The other option will be in Martian soil, they say about 10% moisture is available. So if you have a mechanism to harness the moisture from Martian soil, and by electrolysis or some process you are able to split it into hydrogen and oxygen, that hydrogen can be used for methane synthesis. There are a lot of other avenues open, and similarly if you are landing in moon, based on resources available in moon, what can be done for further propulsion? That's also another area which is open for exploration. And the development of hybrid propulsion system, I think morning VSSC team mentioned about it. Here the basic problem is when we have a solid fuel and a liquid oxidizer, low pressure instabilities, combustion instabilities is a common problem. So here what is required is basically a CFD analysis of the pyrolysis of the solid fuel and the evaporation of the liquid fuel and their interaction. Basically a kind of CFD analysis is what is required here. And we also have some development of green hypergolic propellant. Like when you have a fuel and oxidizer, normally it needs an ignition system to start firing, right? If you have a kerosene, kerosene does not simply on its own start firing if you keep it in air, you need to start ignition. But there are fuels and oxidizers which you bring together automatically it will catch fire. They are called hypergolic fuels. We already have these hypergolic fuels used all in our spacecraft systems, like monomethyl hydrazine and nitrogen tetroxide combinations. But these fuels are not very good for presence of humans. They are partly toxic and they are also not environment friendly. So for human missions, we want to have different, more health friendly, I will say human friendly or health friendly fuels which are less toxic. And towards that, basically we are working on kerosene-based fuel with a suitable oxidizer, so that, of course, some initial experiments have been done, ignitability tests have been completed, and we are trying to use hydrogen peroxide as the oxidizer. So some work is going on in that area. If somebody comes up with some other alternative of green propulsion system, that also will be useful. And another area is many rocket engines now are started once, and once the operation is over, it is stopped. And occasionally it will be useful to have the second firing or third firing of the engine instead of going in one straight route. So for reignition, you need some other special systems. There are different options like laser ignition, spark torch ignition, which are being explored by VSSC and LPSC. Actually, IPRC is working on another concept called acoustic igniter. Basically, what we do is, if you can have a nozzle in which you can generate a supersonic jet of the fuel gas, and then it is impinging on a surface so that shock waves are generated. At the end of that, the temperature of the fuel gas will be more than its self-ignition temperature. Every fuel gas has got something called a self-ignition temperature. By means of shocks, if you can increase the temperature to self-ignition temperature, at that point you add a bit of oxygen, automatically it will catch fire. That's an advantage. It's a passive system, very reliable system, which can be used for multiple startup and shutdown of engines. That's also being explored. And this throttling of Vikas engine is another area. Now you might have seen that in the SpaceX, Elon Musk vehicles and all, they come back to the launch pad and rest back, The engine rocket lifts off, fires for some time. After doing the stage, completes its work. The stage comes back and sits in the launch pad. For such recovery systems, you need to have same engine operating at a very low thrust also. So you need to do what is called throttling. And when you do throttling, once again, combustion instability kind of problems are common. So some experiments are going on in that regard also. And
sir, you can, in general, you can just cover, sir, because this is...
So we have some experiments going on for this air breathing propulsion area. That's also being done. And another area is this thermal barrier coatings. We have coatings with zirconium oxide and other materials which can withstand up to some 1000 degrees. Now we are going for even higher temperature capability. And you need to have ceramic composites. If you are talking about space travel and coming back, for re-entry missions, you need a lot of high temperature withstanding ceramic tiles. Those developments are also initiated, maybe in combination with CSIR. And we have some special refractory materials where normally refractory materials, once it's subject to a high temperature, it will develop some small cracks. And because of the cracks, it will start debonding. If we can have some self-healing material, the material itself will have characteristic to close the crack, then it will be advantageous. Some such developments are going on. And there are many other areas related to welding, because we are working on integration of stages and engines. Like we need to connect titanium with a stainless steel pipe, or aluminum tank with stainless steel pipe, and we need to connect very high thickness parts. So because of that, lot of work is going on in the welding area, friction welding and flux activated welding. That's another area. And one more area is this investigation of chill down of large area, large diameter cryogenic pipelines. We have large cryogenic pipelines which need to be cooled from ambient temperature to something like 90 Kelvin, 77 Kelvin and all that. How to do it efficiently without encountering any problem. That also some analytical studies of two-phase flow and chill down are being done. And there are many other automation activities. I won't call it R&D. It's more like a development and automation, so that manual role is reduced. And in future, there are other activities like additive manufacturing, laser welding, and laser assisted integration. These are all questions where even the problem definition is not complete. For example, our next launch vehicle, NGLV, it will be, when vertical, it will be more than 100 meters tall, and the diameter is some 5 meters. And as you can see in the bottom photograph, it is planned to be integrated horizontally. So when you have different cylindrical systems, all of them might be brought to perfect alignment so that the vehicle can be integrated. Whether for that purpose, we can have some laser-based tracking systems, and based on that sensing, whether some adjustments can be automatically done. This kind of some advanced fixturing concepts are also being worked out. And there are other areas where instead of weld, for example, weld joints are now subject to X-ray. For small weld, small thickness joints, whether eddy current testing can be doing the job, and whether machine learning based defect detection in radiography images. Radiography images are now visually manually checked by human beings and interpreted. Whether that can be automated, all those questions are being addressed. Okay, thank you. I think maybe I had to rush through because of the limited time.
Thank you.
Thank you.
Thank you very much, sir. Anyhow, now we are not giving a chance for questions. We have a particular session for discussions alone. So all the speakers will be available here. So if you have any queries, we will clarify at that time. Okay, please go ahead with the next presentation.
Want to ask any question to us?
No, not now. Yeah.
Thank you, sir, for such valuable information. Now I would request Shri Nishant Kumar, Deputy Director, Capacity Building and Public Outreach, ISRO Headquarters. He will be exploring the documentation work related to research areas in space. Sir, please share your experience with us.
Yeah. I request Nishantji to finish in 10 minutes. I think you can do that.
Yeah.
Okay.
Respected Chair, Co-Chair, Director CBPO, all the dignitaries, faculty members, and all the delegates, a very good evening to all of you. My presentation will be in two parts. I'll just take 3-4 minutes. Already, as sir has told, research area in space document 2025, which was released by today by Dr. B. Narayan sir, and it has been uploaded at ISRO website. You can find out it is coming in Flash. So just I'll navigate it, what it contains in quickly, and then I'll also highlight little bit how and what are the things we can take care while preparing the presentation. If you see in research area and space, the contents, there is already, I'm not going on detail in content, there are launch vehicles, human space program, satellite technology, then we have Earth observation. These are the major areas, space science. We also have space policy and management. So all these areas have new topics. Many of the topics are not covered in previous areas, and like marine biology or you can find out that is something different topics are also covered here. And urban climate or urban planning, this type of topics are also there. So you can refer and go to it. Then there are few annexes. I'll just go through it in annex mode. Yeah. Classification, I want to highlight already our colleagues from ISRO has presented detail about their research area and all these things. So in general, we scientists or in science, we used to classify the things. But one submission or one additional point I would like to say, when you see the classification, there are, means it is like a vertical classification, but there are a horizontal way also where we can look the problems. For example, suppose there is a geoscience problem, it may look from geoscience perspective, but a data scientist or a computer scientist also can collaborate if he or she is going through that problem area with collaborating with a geoscientist and other things. So we should not go, okay, one area is only for geoscience, then only geoscience can happen. Of course, as NEP, National Education Policy also emphasized, we have to see interdisciplinary aspect. So we urge all of you, please go through it, even it is not from the content, but the overall document also. Now at the bottom, spelling on the topics and other things have been covered. Yeah, there are three annexures, so just. There are annexures where the detail of what are the things need to be provided, it has been given at the last, like biodata application for grant in funds. I'm just going to put also in a short presentation. And have to look into it, because often if you go through all the annexures and guidelines, the revision time can be reduced. Means whatever you are submitting may go in one iteration and can get cleared. So whatever rules and regulations are there, that form be detail of technical proposals, that is also there. And the grant and other things are there. The terms and conditions are mentioned. Then if you go at last, there is a coordinator list from STIC and RACS, and their email ID has provided, like regional academy to contact in which area and which location. So this coordinator details, their email ID and other provided. For our central region, the STIC, host STIC is MNIT Bhopal, as well as Regional Academic Center at IIT BHU. Now I'll just quickly present a small presentation. Just a minute. I sent you a presentation. Where it is? नहीं, एक और था ना? आपको WhatsApp मिलेगा? नहीं, just whatever. गड़बड़ हो गया, लेट लगेगा. Okay. Okay, no issue. You can go ahead. I'll manage it. No issue. Okay. What we you can just download it. No problem. But we are going to cover what my presentation covered. It's some wrong. It's not opening. There are 6 aspects or 6 questions which need to be answered, and I believe I'll try to answer it. Let it be in abstract form. Probably we can answer it. The first question is who can submit a proposal, right? So any PI, any professors or any researchers, any scientists who are studying in, who are part of academic institution located within India can submit the proposal. Okay, but only condition is that the age of the PI, the principal investigator, should be less than 65 years. Means total suppose project proposal, if you are putting for 3 years, he should be at least for 62 years. Means it should not happen keep project proposal duration, it is going beyond his superannuation period. So that's one condition. And there can be co-PI, as many number as co-PI from all the institutes. There is absolutely no problem from co-principal investigator perspective. Okay, but while we are submitting in STIC or RACS Regional Academic Center, we should have co-PI from one co-PI we should have from MNIT Bhopal, and one must be from when we are submitting to Regional Academic Center, it should be from RACS ITBHU. That's the one part. Then the next question is come. How we can submit the proposal, and what is the process of submitting the proposal. The research area and space, all these things has been documented in the document. You can go ahead. The research area and space document, research area and space document, it has briefed the proposal detail. What you have to do, you have to select your area of interest which you want, and then prepare a proposal. You can send to the STIC or RACS coordinator, who will evaluate or it through their committee or whatever mechanism is there, and it can be forwarded to respective ISRO centers where the originator of the project is there. But sometimes it may happen that you prepare the proposal, you want to get it connected or get it vetted with ISRO scientist also. You directly write to the center with copying this. You may prepare a draft proposal and you request they can have a look on it before submitting the final thing. And but it should not happen. I just want a means just I made some 1 or 2 page script and just send it. You have to do we have to do some serious work, and then we can expect the response from the ISRO scientist and other thing. While writing, please prefer your official email ID, because nowadays people may worry if you suppose personal or Gmail, whether it is fake or right. So as much as possible, we should use official email ID for communication. That's one aspect. Then the proposal after the process, next process is after from the STIC or RCS center, it will go to ISRO centers. ISRO centers will do its technical evaluation, or it will go through it. Sometime it will go 1 or 2 or 3 iteration modes. Sometime it may get it clear in a short period of time also. And then it will refer to ISRO headquarters. And there is an appropriate committee like Joint Management Committee, Joint Policy and Joint Policy Management Committee. No, it is not. Okay. Joint Policy Management Committee. So all these things, all these committees are there. And if committee have been clearing, then it will be awarded to, a project will be awarded. Okay. So this is, these are the things we need to take care. Then project will be awarded. And then project will be approved for sanctioning, and Department of Space will release the sanction based on applicable procedure. Sometimes there will be some changes in procedure and all these things. So, but fund will be released for 1 year of grant in general. And then next year again this review will take place. What is the progress of the project? Budget will be estimated. The center will take a call, and they will refer to the JPNC, JPC committees, and next year grant will be released based on last year expenditure and requirement for next year. This is the overall process, and we go through it. Any intellectual property which will be generated as an outcome of the project, it will be shared to all the contributors equally in publication, patents, and all these things. So that's from the question part is how. Then the next question is come where to submit, right? So where to submit, I have already answered. You should submit at the STIC and RACS for this regional academic center. Another question next will come, when to submit? कब जमा करना है? When to submit the proposal? Is there any last date? As sir has told, the document is valid for 2 years up to 2027. But if you submit early, there are scope you can get the proposal early, because suppose someone else has submitted and you have also submitted, then it may be means whoever is better submitted, or if someone has awarded and work has started, then second person, even though it may be a valid or very good proposal, it may have to it may not go through it. So as early you submit, but it should be proper, and the chances of acceptance are more. But one area, whether one proposal only can be submitted, no, you can submit as many areas, because it is area, it is not very specific deliverables are there you can think of, but there should be programmatic linkages to the ISRO and Indian Space Program. I believe the last questions, I think I have covered what, when, where, how. Yeah. Then last question is why? There are some why. What is the procedure? I have submitted, but I am not getting response. I have submitted, but very delay response is coming. No, I am not having update. Or why my proposal is not gone through it, even though I have submitted with. So there are evaluation criteria in general what we follow. Number one, uh, we should see the overall novelty in methodology, novelty of the project. It should not be rediscovery of the wheel. Then methodology, clarity in methodology. How much proposal is clear the methodology? That's we have to see. The third thing is suppose you have methodology is clear and you have some novel ideas also, whether overall feasibility or not. But it should not happen. I'm just daydreaming and it's a very big project, but it's not feasible overall perspective. So this is third part. Fourth part, we have to see PI's expertise in that area, whether PIs have previous publication, previous project, and co-PI's expertise. Fifth thing is institutional aspect and institutional facilities what are available. But again, there are few questions in between. I think our policy does not differentiate between a government funded, private funded or joint funded college. So it is applicable and all are welcome. Yeah. So this is the third part. And this is the, so anything is there fine, but and the fund is, then last is budget. How much budget I should project? Budget, there is no budget limit as such, but budget should be your, it should be proper that you can do the project. At the same time, it should not happen that I want, normally if suppose for same outcome there are two, higher budget and lower budget, generally lower budget will be preferred being a government institution. But whatever you are projecting, you should be able to do it. That you have to take care, you have done, what are the equipments and other things are required. Manpower, suppose you require that we have mentioned in our website, JRF, SRF and that appropriate salary you should pick. And we should not go very high budget also or very low budget also. It should be just in it and should be able to do it the project. Similarly, we have travel and miscellaneous grant at the rate of 3% of the project budget. So these are few things which can do it. Sometime due to sometime it may happen that project might have gone iteration. Sometime it may, and it may take some more time to get a response. Sometime it may happen that you have submitted the best proposal, but it has not gone through it. It may not be your fault. It may be because some work might have initiated at the back end or someone has taken the work. So I urge all of you, each one of you, to please submit one proposal or two proposals of your area of interest at the earliest to your STIC and Regional Academic Center of Space. And thank you very much.
Thank you, sir, for your valuable insights. Sir, if you want to ask any question.
If any further questions are there, we will take it in the discussion stage. So we will move on to the next presentation here.
We have Dr. S. Shankaran, Deputy Director, Satish Dhawan Space Center, SDSC, Sriharikota Range, with us in online mode.
Yeah.
Sir is going to share with us the research areas related to SDSC. I request you, sir, please present your PPT.
Shankaran sir, I request you to restrict your presentation to 12 minutes. Okay, yeah. And this is from space our this presentation.
Yes, sir, you are
Yes,
audible.
please go ahead.
Yes, sir, you are audible, sir. You are audible.
Yeah, respected Dr. Paul and the co-chair from the institute and all the dignitaries on the dais, my colleagues, very to all of you. Actually, I am presenting some of the research areas of Satish Dhawan Space Center. Before going to the research area, let me just tell what is Satish Dhawan Space Center is all about. Actually, it has got many responsibilities. You have a huge solid propulsion production center, especially on solid rocket motor propulsion system. And we have static testing and environmental testing like static testing of solid rocket motors, and special purpose motors and pyros and the igniters, etc., etc. And also having environmental testing like we have vibration testing, ionic oxidation testing, thermal commissioning testing, constant acceleration testing, etc. we are having. And also coming to the range operations, we have radar and related systems and liquid servicing storage and propulsion system. And also we are having the systems related to the launch vehicle integration and launch pads, state-of-the-art launch pads we are having, and the integration and preparation facilities. We are having huge facilities for the launch vehicle, for the present launch vehicle like our PSLV, GSLV Mark 2, LVM3, SSLV, etc. So also we have Gaganyaan guided systems, we have orbit module preparation facility, etc. So we'll be presenting some of the highlights and what we look for from the academy. So this is just a glimpse of the central R&D activities at SFET of SSHR, and also I'll touch upon some of the titles which we are look for and support from the academy. See, the one first you are seeing is the development of Prayam, which is called precision instrumentation amplifier, which you are developed. In this regard, we are also looking for a kind of a data system, like a PSA Express kind of thing. So anybody is coming with the indigenous development of PSA Express high-speed data feed system, they can approach us. And also, the next one, I'll just go through the slides, will be easier. I'll just come over that next one. This is one which I am talking about. We have developed this with the CDAC. I am also looking, we are also looking for academia coordination. If you are coming with such a system, where we want to have some kind of a data feed system, which is high-speed data feed system, like a PSA Express, they can please contact us and we can have a collaborating program. Next. So this particular thing directly will be going for the measurement of various data, which is going to be collected during the static test of various subsystems and solid rocket motors, etc. So it will be very useful for us. Next, this is the one important system. Since we are the launch vehicle center, we are looking for different issues related to launch vehicle lift. So one such thing is we have to simulate the launch pad, and we have like a jet deflector, we have acoustic system, acoustic suppression system, and ignition overpressure study, vibration study. There are many things. So in that we need to simulate the ground system. For that we need a kind of a surrogate gas, whether it's a cold flow or a hot flow. We need a gas that is high temperature, high pressure gas system. Currently, we are going for some kind of a hybrid gas generator using a paraffin and a geoxygen. If anybody coming out from this kind of system now, it will be very useful for us. So we are looking forward. Anybody coming with a high pressure, the temperature of the order of 3000 Kelvin to 3500 Kelvin, the pressure ranging from 40 bar to 100 bar. Anybody is coming with a system, we will be ready to take it up, and we can work it also together. That is the possibility is there. So this is not there in the proposal. I am just presenting. What are there in the proposal, I will be touching only the slides and the title a little later. So you can see that how it is being fired here. So we have multiple nozzles. There is a requirement of multiple nozzles. My friend, our Pradhan sir, has presented earlier that future launch vehicle will have multiple nozzles. So that has been tested, and for the lift-off issues, we need to study the aerothermal issues, supersonic flows out of the nozzle, jet deflector impingement, and aeroacoustics, aero suppression. So many studies are required. It will be very useful. So academia is coming with a gas generator which can give a high pressure and high temperature highly well. And similarly, like this, we will simulate some kind of a lift-off scenario of simulate the launch vehicle system. We'll be doing many tests on this. I just showing a glimpse of it. Yeah, you can see that this is a kind of a jet deflector. We call it a flame deflector. If you go to the literature, you can get many data in the literature. So this, when the multiple jets, as you see here, there's a multiple jets are here. These multiple jets are here. When it is impinging on that supersonic jet, multiple jets are coming, around 27 jets are coming. So we need to study all those things, for which we need a cold flow and a hot flow. Surrogate gas is required. That is what I am asking for an application. And you see here, this is a typical system which you are seeing here. And that the jet deflector and that multiple nozzles, you can see the top of that. So we need to study those things for various applications. So I am requesting once again academia, if we are coming with a suitable model, will be very good. Yeah, this is another one. We have a huge vibration systems called 16-ton two number, that is 32-ton electrodynamic shaker vibration system. We are looking for indigenous development of the existing dual head expander. It is a magnesium thing. So you have somebody is having a huge 4-meter, 5-meter dia dual head expander with a magnesium alloy. It can be weldable, so it will be very useful. We are projecting for the future applications. We are looking forward to such kind of materials also. Yeah, we are just showing how the requirement will be. You can talk to Nishant. You can get our contact. You can contact us. If anything is useful, interest, and jointly we can do. We can take it. Due to paucity of time, I'm going very fast. So, if you see here, there is a 10 proposals available in the research area proposals. Range operation related 10 numbers are available. Environmental and static motor performance and test facilities, there are 2 proposals available. Vehicle assembly and integration and launch facility related one proposal is available. I request kindly go through this proposal. If anybody is coming out with a proposal, we are very happy to consider them and recommend. So these are the, I already told you, these are the things related salt water production, range operation, liquid propulsion, storage, service, salt water production and environmental test facilities, and safety related. Hazardous, anybody is doing detection studies, any explosion studies, propellant safety studies, anybody is doing that, we are very happy to receive them. Proposals are very much important for us, and with the advent of Gaganyaan program, these are very important. Launch vehicle assembly and launch pad are projected laser related alignment is also very important. So I'm just giving the title which I am not going through. These are all the first 7, 8, 9, 10 titles are related to the, we have a med facilities available because very important for the launch vehicle lift-off. Med prediction is very important. So we have a very good team at SHAR. So there are good scholars working on this area. Anybody is giving a projection on this area, the title, they are very, we will be very happy to consider those. I just given a title, enhancing space-based launch vehicle safety through expand Doppler weather radar simulation in the NWF model. So this is a numerical weather prediction model. If anybody please go through the proposal and come back on this. Other one is also hybrid data assimilation techniques for upper wind, monsoon rainfall, rapid cyclone and thunderstorm, lightning prediction. Lightning prediction in launch environment is very, very important and very crucial and very much required, so people can present this kind of titles studies. And the AI-driven wind forecasting, again, we have regular balloon we are every day we are using for the upper wind, that is Sonde, with the Sonde. So these are the data which are important to get the velocities and what kind of direction the wind is there at different altitudes is very important. So those areas we are looking for proposal. And we are also looking for a very short range forecast of near-surface winds for space operations. The rainfall prediction is very important. This is again, I request you to go through the proposal and look for a detailed description of this area. So, water isotope analysis over the East Coast. And ionospheric observation using ionosurvey is also people can go through it and come back if anything is required. Yeah. And I'm coming to the other one. This is related to the launch vehicle lift-off scenario. You are aware that when the launch vehicle is lifting up, a huge acoustic is generated due to ionic flow coming out of the nozzle. So we need to know where the sources are located at different frequencies. So we are looking for a supersonic jet noise source localization technique using a microphone array with the appropriate beam-forming algorithm. If anybody is coming with this particular project, we will be very happy to receive this and recommend it. It is very important. We already initiated in a very preliminary mode. If anybody is coming with a good understanding and the studies, we will take it up. This is the modeling and evaluation of damping in threaded joint load cells and its impact on measuring damping force component. So this statical thrust load transfer is generally through the threaded joint. We all know the thread damping is important with reference to the dynamic thrust measurement. So this objective of this particular topic is to model and experimentally evaluate the threaded joint damping for unsteady load transfer. I'm telling you, if you are having a difficulty in doing experiment, we can take it up. But if you are getting a theoretical support on this also, very much welcome. And this is the automated stage separation, stage preparation with minimum human intervention. Again, our Siddharth sir has given one thought process on this. We want to reduce, because it's a highly hazardous area, we want to reduce the human intervention, and we need to do a lot of repetitive work. So whether it is possible to do the automated rocket stage preparation procedure with minimum error, because error is not tolerated here. So like you see, high pressure test console is there, pneumatic test console with 300 bars upstream condition. So it is very difficult to put all the time with the bulletproof things and a human being has to operate, for which we can go for AL and ML in order to increase the launch frequency. Data analysis automatically using the artificial intelligence can be used on this. So we are looking for this kind of proposal. Also, something okay, for this we need even a failure mode troubleshooting procedure to pinpoint the leak. We can study the legacy of data and come out with a kind of a software also. We are ready, and the future implication of scale-based stage separation, stage preparation also very important. So with that, coming to the end of the presentation, because due to the paucity of time, I'm sorry I have to rush through the slides. Thank you very much. I'm very
Thank you very
happy
much,
to
sir.
answer.
Thank you.
Okay, sir. My side.
Yeah. Nandita madam, are you available? Just check some people are not there. Yes, yes, she's there. She has shared already.
Yes,
Nandita madam,
okay.
1 minute. Actually, we are running a little late, so I restrict you. I request you to restrict the presentation to 12 minutes, madam.
10 minutes. Okay.
10 to 12 minutes. 10 to 12
Okay.
minutes.
I'll,
Okay,
I'll try
okay.
my best. Yeah.
Yeah.
Okay, so thank you everyone for joining, and I'm going to discuss about the research areas of the Physical Research Laboratory. As you know, this institute was founded by none other than Dr. Vikram Sarabhai, who is considered as father of space research in India. And I would like to begin with a quote. Of his. He said countries have to provide facilities for their nationals to do front rank research within the resources which are available. It is equally necessary, having produced the men who can do research, to organize task-oriented projects for the nation's practical problems. And this is precisely what we are doing today by joining this ISRO Academia Connect for the central region comprising of Uttar Pradesh, Chhattisgarh and Madhya Pradesh. So I'm going to discuss about the research areas in which PRL is engaged, and there are 7 major divisions of PRL. They are located in 4 different campuses in Ahmedabad, Udaipur, Mount Abu. And so I'll go one by one quickly, and I'll try my best to finish it in time. Is the slide moving? Yeah. Okay. So, so we are conducting solar physics research at Udaipur Solar Observatory, which is a leading research center for studying the sun hydro observational and theoretical research. Basically, we are interested in studying solar flares, evolution of solar magnetic fields, and forecasting solar flares. We are also interested in study of solar oscillations, which which is part of Global Oscillation Network Group. There are six identical instruments 60-degree longitude apart around the globe, which are having identical instruments to do oscillation studies on the sun. And Udaipur is one of the leading centers of this six station network. We have also got a radio telescope and a 50 centimeter optical telescope that is doing high resolution studies of the surface of the sun. And Udaipur group is also involved in Aditya Alpha space mission and National Large Field Telescope, basically, which is a 2-meter class optical telescope. It's a ground-based instrument to be installed in Himalayas. Our chairman, ISRO, Dr. Narayan just mentioned in his inaugural address about he highlighted the success of Aditya L1 mission, which went to the L1 point, and it is giving good data, terabytes of data, and that has been kept at the website called pradhan.isrc.gov.in. I would request and encourage researchers from the central region to go through this website and try to download the data and see if it is of use to you and of interest, so that one can do collaborative research with the PRDN scientists. Aditya Alpha, as you know, there are seven payloads aboard Aditya mission. There are four remote sensing and three in situ instruments. And if you want to know the details about this capabilities of these instruments or payloads, then you can have a look at the special issue of Solar Physics Journal that has come out in 2025. The second division is on space and atmospheric sciences. In PRL, they are conducting research on full atmospheric dynamics and space weather, and basically they are interested in various atmospheric layers and also the wave dynamics. Also doing lower middle atmospheric composition and dynamic studies, trying to characterize the properties of aerosols and its impact on Earth's radiation budget, trace classes, volatile organic compounds, and their effects on the atmosphere. And for this purpose, they use different approaches: ground-based, ship-based vehicle experiments, aircraft, rocket, and even space-based instrumentation, and which is also supported by modeling and numerical and theoretical studies in the division itself. One of the highlights of this division is that they built, conceived, and designed and developed the Aspects instrument, which is Aditya Solar Wind Particle Aspects, which is now operating on board Aditya L1 mission and is giving good data. It has two sub systems called STEPS and SWISS. Basically, they are measuring the energetic particles of solar wind in different energy ranges. And just to give a brief highlight, that both aspects and both instruments on board aspects are performing very well, and the data when compared to other NASA spacecraft is matching very well, and that gives us confidence in the measurements that we are making through this instrument. Another upcoming mission of this division, Space and Atmospheric Division of PRL, is the Disturbed and Quieting Ionosphere Thermosphere System at high altitudes, called DISHA. It's a proposed mission, twin satellite mission, which will have two identical satellites. One will be orbiting in a polar orbit close to 90-degree inclination, which is a high inclination orbit, and another one in low inclination, which is about 25 degrees. And it has got several instruments on board proposed, which will perform the neutral density measurement, plasma drift velocities, electric fields, etc., and so on. They are also not only studying the atmosphere of the Earth, but also studying the atmosphere of other planets. So they have proposed instruments on Mars mission, like Aspects and SWIM, similar to the instruments like Aspect, which will be called Prime. And they have also got proposed mission on Venus orbiter mission, which are for NAVA and ERAT. The prototypes of these two are being fabricated at PRL. Fourth and important active group in PRL is doing research on planetary sciences, and there are four major divisions on which this group is conducting research. One is atmospheric interplanetary science, planets, and laboratory studies of planetary samples, planetary remote sensing, and satellite payload development. So as I mentioned, we have very good laboratories for planetary sample studies in order to characterize the meteorites and rocks from other planetary bodies, etc. Basically, all are aimed to understand the early solar system processes, to get their age, composition, etc. And payloads have also been developed for different missions, planetary missions. For example, APXS instrument, that is alpha particle X-ray spectrometer, and solar X-ray monitor on Chandrayaan 3 and 2 respectively. This division is also doing work on surface features on planets and moon, basically volcanism, impact cratering, space weathering of the moon, and glacial entropy processes on Mars. And they are involved in the planetary rock sampling technology project, which will important for future in situ and sample return missions, which have been highlighted in the previous talks by several speakers who spoke before me. As active group in PRL, it has an observatory in optical and infrared wavelengths, which is operating at Mount Abu, and these are conducting research on stellar objects, galactic compact objects, active galactic nuclei, and comets, etc. The main highlight, which even the ISRO chairman today highlighted in his inaugural address, is the discovery of exoplanets using the indigenous developed instruments and telescope in India, which is from the Malappuram Polytechnic. Sorry. Okay, so this highlight of this telescope is measuring low, very small radial velocities of exoplanets, and several discoveries have already made by using the FARAS 1 and the FARAS 2, which is PRL Advanced Radial Velocity Aquaspine Search Instrument that has been developed in-house for understanding the exoplanets. Chandrayaan 2, as I mentioned, solar X-ray monitor is a very important instrument which has led to several important studies in solar research by identifying sub-8 class to X9 class the bandwidth range of intensity of flares. Then there are three other groups which are engaged in optical and molecular physics, structured gain and non-linear optical effects and optical parametric oscillators. Quantum science and technology, basically quantum communication and sensing group. These are all experimental groups which are working in laser induced radar spectroscopy and molecular fragmentation, which is, and again there is a critical group on search of atomic clock habits in this group. We have a very good astrochemistry lab, which is engaged in study of physico-chemical nature of astrochemical sciences and other aspects, including the impact and shock processing on the astrochemical ISIS. Then we have luminescence physics laboratory, which is one of the best laboratory in India with luminescence dosimetry of natural and synthetic material possible, which is involved in dating of meteorites, Earth surface process, and planetary analog samples and space dosimetry. Then there's a geoscience research group, which is basically including all the areas possible on geochemistry, terrestrial atmospheric chemistry, paleoclimate, hydrology, solid earth, and earth surface processes, which is basically to identify and understand the contemporary and past processes through their chemical and isotopic signatures in natural repositories of the earth. And then lastly, there is a theoretical physics division which does fundamental physics research on neutrino physics, flavor physics, beyond standard solar model physics, collider physics, and condensed matter. And there's a small group which is also working in deep machine learning in this particular group. So this, as you can see, there is a diverse area, diverse topics which PRL is conducting research in different groups. So here are some of the proposals that you can listed in the research areas, and there's an email address that you can write to me if you like. Thank you.
Yeah, thank you very much, madam, for this
talk and completing it also on time. Okay, thank you very much, madam.
Sorry, I interrupted. Yes, yes.
Our next speaker for this session is Sri Vivek Kumar Khare, Division Head, Human Space Flight Center, Bangalore. He will be delivering ideas on key research areas in HSSC. I request you, sir, please share your views.
Yeah. This is a new center what ISRO has set up, that is Human Space Center. So a lot of newer areas they have detected. So a lot of opportunities are there, will be there in this presentation. Gare sir, 12 minutes, please. Gare sir, 12 minutes, please. Restricted to 12 minutes, please. Yeah.
I think that was off. Yeah, now it is on. So we are a very small center, human space flight center in basically based in Bangalore. And I'm working as a deputy program director in crew recovery operations for human space program, as well as division head for crew recovery operation group. So I will start basically from yeah. So here I just captured the glimpse of the activities what we are going forward. This year we will be having first uncrewed mission, which is Gaganyaan G1. Prior to that, we have one test vehicle mission. Same we had in 2023 as TVD1. We'll be having TVD2 this year, followed by the integrated airdrop test and first uncrewed mission. So if you can see on the left side, in VSSC, the launch vehicle is HLVM3, which is human rated launch vehicle Mark 3, which will be used for the Gaganyaan project. And sideway of that, you can see a crew module in orange shape, and the bottom part is service module. So together it is called orbital module. So this will be integrated at URSC. So the main objective for this is a short-term mission in order to demonstrate the safe human transportation to low Earth orbit and bringing them back safely and recovering them. Then coming to the extended version of human space program, we have sustained human space presence. In order to do that, we have Bharatiya Antariksha Station where these orbital modules will be docked. And this Bharatiya Antariksha Station is meant for Indian research as such, and forwarding to the moon landing by Indian astronaut. So at HSFC, we work on the astronauts, we work with the astronauts, and we work for the astronauts. So all the human-centric works where the astronaut is involved, those works are categorized in our SFC. So I will be briefly touching upon the research areas. These are mentioned in the document which is released today. So first one is microgravity research, which is now a hot topic all around the world, and we have the first our ISS XGM-4 mission in the next month, where one of the astronaut is going. So it is just to understand the effect of microgravity on biological, physical, and engineering systems, and a lot of technology developments which requires microgravity in supporting sustained human presence in space. Then I'll be touching upon crew-centric systems, which are sustainably efficient life support system to astronauts, the waste management schemes in space, and their ergonomic considerations, which we have to take care while they are in space. The last one will be the human research, space medicine, and space biology. So microgravity triangle, if you can, pyramid you can see on the left side. We have a space-based and flight-based facilities and ground-based facility where for some 10 second to 20 second we can have the microgravity field by the mean of drop tower, parabolic flight and sounding rocket, etc. And space-based like Bharatiya Antariksha Station, that is the way where we can have a sustained program. So some of the examples I have summarized in my presentation. One is which will be affecting the astronauts when they are in the Bharatiya Antariksha Station, like microgravity combustion, the fire detection and its mitigation. So here we are going to see how the flame propagates in microgravity. So this research scope is listed here, how we can see the convection combustion mechanism and how the flame is getting stretched, shoot formation and droplet combustion, etc. And understanding the influence of gravity on flammability of the material. So what kind of material we should select for the interiors or the exterior of the crew module where we can avoid the fire. So this is one of the area. The next one is microfluid cards. These are the cards where if we want to mix two fluids in the microgravity, so they are very compact and I mean the measured quantity of two fluids can be channelized, and the channels which are available on these cards like chip, if you can see on the right side. So here material selection and its biocompatibility is the main critical thing which has to be taken into consideration. Then here the research scope is limited to development of microfluid. These are the platforms where you can perform various microgravity experiments by mixing the various fluids which are not mixable in the presence of gravity. So it's a platform card like that. There are so many, hardwares which are developed by the various agencies, international. So they are, they are designed to fit into the International Space Station. So they have the space constraint. That's why the size is small. Third one is the bubble mitigation. Suppose in our earth we are having any bubble formation in our piping or in our system, and air is entrapped, how to deal with that. So we do priming here, but in microgravity this phenomena is it is a very really challenging thing to study the behavior and to mitigate it. So this is one of the another area for research. Then study of droplet in boundary conditions and various investigations for spreading dynamics, contact line studies and evaporation during the oscillations and spreading of droplets in microgravity. That is the area which is another area where we emphasize you to come up with the ideas and various proposals which you can think on droplets, it can be formed. Then these are the refrigeration or freezing technologies. See the basic requirement for refrigeration in International Space Station. It is like T minus 48 hours of descent. You need to freeze any sample to the desired temperature with which it has to come down to the earth. So for that 48 hours, these systems should be compact and enough to fit into the space available, and they should be efficient enough to give the required temperature for the descending orbital platform. So this is one of the facility which we also want to have in our space station. Then plantation is a common thing to give the continuous supply of nutrients to our astronauts and all. So this is a habitat to make some greenhouse sort of thing, where we can grow plants which are very rich in protein and all. And with the minimum human intervention, they can be grown. So this is a common area for growing the plants in space. Coming to the crew-centric system, we have a challenge in developing our own flight suit for the astronauts. So if you can see, this is a flight suit which is used in SpaceX. So something like this, but the technology, it is very challenging, because identification of material for doing extravehicular activities and a very large number of multi-layer fabrics which has to be chosen, and they have to be joined together, and their mathematical modeling and validation we have to do before realizing this material. So material selection is the basic key in this area. And coming to human research, space medicine and space biology, it is just what diet we should give to Indian astronauts to have the cultural, add-on, where we can give the Indian food, whether that is suitable to give in the space. And we Indians are deficient in vitamin D and vitamin B12 also. So those areas, with some supplement, we can overcome. Then the last one is how we can increase the fibers or spices. As I told, the cultural thing, our astronauts will be very interested in having Indian food in space rather than the packaged one, which is standardly available.
Garaj, you can go a little faster, another 2 minutes.
Yes, sir, I'm just wrapping up. Then the next one is bone loss mechanism. So it is a nominal phenomenon in space. How to keep their bone mineral density intact with the supplement of calcium and vitamin D, and loading them with the exercise which they have to perform being on board ISS or BAS. And here metabolic and cardiovascular monitoring, this is add-on to our second one, where we will be having their reaction to the various nutritions which are given to them, and their insulin levels, how they are acting, their cardiovascular method, what is pertaining to Indian average human being. So that will be monitored. Then exercise countermeasures, these are just to keep them fit, to do research for a long duration of missions. So here efficacy of mainly yoga and breathing techniques is an add-on other than the regular exercise apparatus which are available in ISS or we will be proposing in BAS. The last one is for the drug efficacy, as I told in my earlier slide, for vitamin D, vitamin B12 and all, whether the Indian traditional drugs, whether are the they are the only supplements or we have to discover new medicines. So that we have to see through our, traditional medicines, whether we can use for their stress relieving, like ashwagandha and all. So, and the drug stability and packaging is one of the part where the packaging every time in space is the special packing, is not the normal thing to fit into the space provided for the drugs. So these are the some of the areas just I have briefed on in my presentation. The details are available in the documents. For the we look forward for the bio people and the biomedical people, if they are available here, to just go through the document and reach to us. So as we are engineers and scientists, so we are not medical or doctors. If you can support us in doing certain studies with medication or bioengineering, to firm up our hardwares for taking the items from Earth to our space station, it will be helpful. Thank you.
Okay, thank you, Gary sir. Before we go to the BH presentation from
Do you
BHU.
want to ask some questions, sir?
Yeah, no questions. Yeah.
Sir, we have one more presentation, sir.
Yes.
Okay. Our next presentation is from Sri Nand Kumar, Group Head, ISRO Inertial System Unit, Trivandrum. He will be joining online with us.
Nandakumar, are you available there?
Yeah.
Yeah,
Is the
okay.
presentation?
Yeah, it's loading. So, Nandakumar, you please restrict your presentation 10 minutes. We are already running late. Okay, please. Yeah.
Okay. Thank you, Paul. So, good afternoon. Myself, Nandakumar KS, and with me, Dr. Radhika, who is working on atom reform technology, is with us today. So, as HSLC person told, they are a small center. We are also still a small center of ISRO. So I will straight away. I'll go to the presentation. Anyway, the one thing I just want to introduce the audience that what is the inertial system, what is the importance, its scope. This is one of the strategic system which I think IASU is only making in India, and this is a technology of pure nature, and this need a lot of multi-domain expertise, long gestation period, high precision requirement, then lot of need for extensive testing, all simulation assembly requirements. Now, why inertial system is used is basically for navigation. That is, the measure of the present position, velocity, and attitude of a launch vehicle, and that will be explained in the next cycle. This is a classic closed-loop initial vehicle where our systems navigate. That the inertial system will provide the navigation input to the launch vehicle navigation the computer. So this slide will explain how a closed loop engine of a vehicle where as per the navigation command which is passed to the computer, the target condition they will compare and the control command is issued. So, and these are the various inertial system which we produce. We have dynamic fluid gyro, ISRO, laser gyro, ceramic servo accelerometer, and using these sensors we are producing the systems, and we are also developing the navigated nails which is used in a majority of Indian launch vehicles. Coming to spacecraft mission, we are developing the attitude and orbit control system. This is for controlling the attitude. We have to determine the current attitude and identify the difference between current and desired attitude and apply torque to minimize the difference. This is a satellite attitude control block diagram which ISU sensors measure the attitude uh, measurement and it is provided to the AOCS. Then the actuators, which consist of momentum wheel and reaction wheel, provide the necessary attitude control. Now, for inertial systems, we are basically providing a number of systems like inertial reference unit, then the momentum wheel assembly and reaction wheel assembly, and we are also providing the solar array drive assembly for positioning the solar panel towards the sun. Then different kinds of scan mechanisms and payload mechanisms for different spacecraft that are also being realized by ISU. And if you see the gyro technology in the global scenario and ISU development, we started late, but we are trying to catch up. We are working on the mechanical, starting with the mechanical sensor to the laser gyro, to the hemispherical laser gyro, and we are currently also pursuing our MEMS sensor development. Then the accelerator roadmap also, we have worked out the accelerator roadmap, starting with the mechanical thickness accelerometer to the resonant Karsh accelerometer, then MEMS accelerometer, and the ultimate atom interferometer-based accelerometer. And these are the thrust areas which what we IASU pursuing. One is the miniaturization using ASIC 3D and 3D packaging and integrated sensor. Then we are also developing the advanced sensors and actuators, MEMS sensors, HRG and atomic dose sensor. Then we are also venturing into the system for aerospace, which consists of multi-sensor layered navigation system, vision navigation system, and AI and space robotics. That is also one of the new area which we pursue. Then, as I told, the development of inertial system require a lot of technology, which consists of optics, of processing, that is machining, then signal processing, photo detector, miniaturization, LIDAR. Then this non-contact machining of glass, then manufacturing process. A lot of manufacturing process we have developed, like what I'm in the next slide, single point diamond tuning, ultrasonic machining, then a lot of polishing techniques like plasma polishing, plasma nitriding, beryllium coating, atomic layer deposition process. See, these processes we have to develop, and we have collaborated with certain academic institutions in India for developing the process. Then these are the further area which we working on. We have electromagnetic actuators, nano reaction wheels, magnetic gear, then smart actuators, micro and nano control mount gyroscope, high-speed bearing actuators, and reaction sphere. And we have set up a high ISRO space typology laboratory for long-term requirement of ISRO mission. Where we have set a lot of facilities, which is one of the best in India, I can say. And some of the facilities are not at all available in any of the Indian laboratories. Then we ventured into the AI and space robotics recently. There are a number of areas in ASP we are working. One is an AI ML accelerator design development, then control design for humanoid, then mechanical design of space robotic system, then integrated navigation system, vision-based guidance and navigation system, which is AI-enabled. Then a lot of reactionless maneuvering techniques, which is used for the humanoid and for catapult robots. Then control strategies, which is very critical for any robotic system in space. Then there are some other development area which is working on the NAVIC and GPS side. These are majority of system dual frequency development, then ionospheric tropospheric correction, deep integration, NAVIC-based commanding packages, which we have already proved in last poem. Then for an inertial system, the navigation software is the key thing, where we have introduced a lot of design novel technique. Then what we are trying to introduce a deep algorithm for sensor compensation. Then some of the techniques also like error compensation. All these things we have some collaboration with the academia. We want to further extend this collaboration with in future also. Then, as far as indigenization, this slide show you how each area we have developed and we have collaborated with a lot of academic institutions in all over India, like IIT Jodhpur, NIT Warangal, IIT Mandi, and even IIST Trivandrum. Then we future also we have plans for a lot of miniaturization like Navic digital, then MEMS accelerometer. Then for all the sensors what you developed, we want to develop sensor electronics using a SIG. So there are some future areas also. Then in indigenous processor, IISc also developed a lot of development. We have a lot of development with IIT Madras. First processor Shakti, which is actually developed with collaboration with IISU. Then we want to further improve the processor where the high performance computing application we want to develop. Then AI and ML with accelerators, that also for the future interplanetary missions, that also we want to develop. Then this is one of the new area which we are working on. This is this camera sensor development. Anyway, Radhika, can you tell?
Quantum sensor development, it is pursued as a next generation autonomous navigation technology, and the end use or the application lies where in the long duration interplanetary missions where there is no external aiding is available. So it is applicable for high accurate measurements of acceleration, gyroscope, as well as the gravity gradient measurements, and it has wide applications in other areas also like earth science studies, magnetometer measurements also. And worldwide also, this is a highly upcoming research technology where technology is already proved in ground and they have tested in airborne platforms also. And in International Space Station as well as in Chinese Space Station also, one experimental module is identified with the cold atom technology, and that is in working condition. And the performance wise, the technology is capable of giving acceleration measurements up to 10 raised to minus 10 g, gyroscope measurements 9 raised to minus 7 degree per hour, as well as since the accelerometers are accurate, it is able to give a gravity gradient measurement of 10 raised to minus 2 micro g per meter, which is very much essential for onboard measurement of gravity and its compensation. And in IISU, we have initiated a advanced R&D, and a cold atom lab is operational where we are cooling rubidium atoms to 10 microkelvin, and then we are doing the coherent manipulation of the atoms, which is required for a gravity measurement. And we have done the atom interferometry also for carrying out the gravitational acceleration measurements. And one of the lab photo as well as the cloud experimental results are also shown here. And we are already started for the indigenization and miniaturization of the different components to realize the navigation system.
Okay, then we are also working for the multi-sensor integrated navigation system for the future missions of ISRO, which use the AI machine learning algorithm. Because of paucity of time, I'm not going to explain this. And the last January, we have done in India first robotic arm deployed in orbit, what we call is relocatable robotic manipulator OM4. This was the first experimental mission by India in the robotics system in India. Actually, this we developed a 7 degree of robotic arm, which done each one like in the space. All the systems what we done is a indigenously developed system, and this has performed well. Then this is the half humanoid which we have developed, which we are going to develop for the G1 mission. We are almost in the final phases of development. And this space research area in the document, what we have proposed in the space robotics, we want a collaboration on many of the areas, like dynamic modeling, then guidance control for fleet, then AI-based object grasping, because these things require a lot of research paper, research input, which IISU cannot pursue alone because of the limited manpower. So we need a lot of collaboration with the academic institution. Then another thing is lunar surface navigation, which is it is a novel idea that all the details are available, because this is the first time we are proposing with the micro IMS and other lidar and visual odometry. We are proposing a independent navigation system which is not based on Earth communication and reference. That is a novel idea. Then one more research area what we are putting is a pulsar-based absolute navigation for advanced space mission. This is actually we are proposing as a new development. So thank you very much.
Thank you very much, Nandakumarji. Yeah, thank you very much. This is about the Regional Academic Center for Space. So we know that we have set up 6 Regional Academic Center for Space across the country, and one such center is located in IIT BHU. So we will explain some of the activities taken up at IIT BHU. Sir, I request you to restrict to 10 minutes. Sir.
Okay. Good evening to all of you. Where is my presentation? Yeah. So, as a JPMC and REX committee member, I'm going to talk about the REX at IIT BHU. So, my name is Abhishek Kumar Srivastava. I'm working in the Department of Physics at IIT BHU. So, basically, as we are aware that the REX at IIT BHU completely aligns with the Indian Space Research Program and as per the mandate of ISRO that is there. And its all activities are completely following that ethos. And this came into existence in less than 5 years. You can see here the timeline when the MOU was signed by ISRO CBPO director and the director IIT BHU on 23rd December 2020. So it is less than 5 years when this RAC is at work. And here are the collaborative institutes which are comprising with the institutes in Uttar Pradesh, Madhya Pradesh, Chhattisgarh, and some universities also. But apart from that, many co-PIs are from different other institutions as well as from different universities in this region. And the major activities of this RAC is a long duration research proposal for 2 to 3 years, as well as short duration projects for undergraduate students and their research. And this is for 6 to 12 month duration. If we glance through some data in the first call, so you can see here that total 30 projects were received in the first call, and it were processed as per the norms, in which after the rigorous review process, 10 projects were sanctioned with the total grant of more than 1 crore rupees by ISRO, and research were ongoing. And this block diagram efficiently depicts here that these research and various PIs, they are collaborating with the different institutions, different ISRO centers, SAC Ahmedabad, IRS Dehradun, PRL, HSFC, VSSC, and many more. Similarly, when we go to the data in the second call, so we received 31 total proposals, and after the rigorous review process, 8 projects were sanctioned. In the JPMC meeting, we were present there, and there was a rigorous review. In 2023, with almost 1.5 crore sanctioned grant, and again, these are the collaborating ISRO centers on various thematic areas. So the third cycle is in ongoing process, and we received 31 proposals in this third call in this year, and some proposals were already reviewed while some are under review, and we can soon expect the JPMC review process in the latter stage. Apart from research activities, the various PIs from different projects which are connected to RAC, they are connected to other programs. For example, they are conducting the internship of undergraduate students. They are participating in various institutional events. The expert talks and co-PIs talks were organized in different departments. And not a big conference, but some small conference and workshop were organized here under these projects and research areas. So this is simple procedure to apply for the project. Once need to write the project, so there is a kind of point here that PI is encouraged to include a faculty member from one of the associated institutions as a co-PI for the joint submission. Proposal, one time one PI can write only one proposal, but in both the categories. I don't know what is happening here. Okay, and the research topic, this is a very important point. The research topic must align with the research areas outlined in ISRO's document. That means it must be, aligned with the research mandate by ISRO. You can find out these details and the ISRO centers and related details on these websites. And this is mandatory that the project proposal includes ISRO scientists from different centers which are having the matching expertise and where the PI and co-PI could collaborate with the ISRO. And this is the usual review process. All submitted proposals are screened at the RAC at IIT BSU, and they are then forwarded to the respective ISRO centers for the review process. There is a more than one referees that they can review the whole proposal, and based on their comments, the selected proposals may be invited for the presentation in front of committee members at JPMC, where they need to deliver the talk. And ISRO center and JPMC members, they further select the successful proposals, and then the PIs are being contacted for the project grant and so on. So RAC IIT BHU is delivering very well in last 4 years. You can see here the range of thematic areas, both in space science and technology. You can see some proposals. They are related to the various electronics and communication. Some are related to the astrophysical concepts, solar and heliospheric research, and some are related to the communication systems and related research, and so on. So this is the list of 8 projects. This is the second cycle related projects, and you can see here there are a variety of projects which are involving various areas in space research, basic space research, as well as the technological development and related research. So these are the list of the projects which were sanctioned by the RACS IIT BHU. I will glance through some results which were very compelling, and these projects were granted by the RACS IIT BHU. So this is by Sivam Verma at IIT BHU and related team, and they have developed the solid state gas sensors for basically detecting the critical rare atmospheric gases, and this could be useful research for various atmospheric science related missions. I'll not go to the technical details. So they have developed this sensor with a very low power consumption, and that could be important for the space applications. And in this study, you can see here the Shreyans Jain and group. They are basically trying to understand the metabolic biomarkers as a predictive response to the radiation exposure. They did some mice model and they simulated the data. So what they are trying to get, they are trying to get some very useful database with some sensitive information also. They are trying to publish peer-reviewed papers. And the most important thing is that they have generated some very skilled human resources, manpower in form of PhD student who could do this kind of experiment, and this could be a valuable research when some space missions are concerned where astronauts are involved. This is very famous research area. This is carbon filament reinforced polymers, and they are the usual waste products when some space program and related instrumentation are being done. So this group is trying to recycle this CFRP waste, and they are having some very significant outcome. So they are reclaiming the carbon fiber from CFRP waste through microwave thermolysis. They are producing these composite filaments using carbon fiber reclaimed from this waste, and they are making some parts as a 3D printed using these filaments through FDM route, and they are trying to understand theoretically these things by using finite element analysis and numerical simulation. So you can see the breadth and range of these projects which are being offered by RAC there and IIT BHU, and it is not limited to only those things, but here some projects from the mathematics department, they are trying to put some algorithm that is useful for the denoising and enhancement of the image data, and this could be useful for imaging observations, satellite imaging data, and remote sensing applications. Basically, they are using the denoising with a Gaussian filter, which is analogous to solving the diffusion equation with the initial conditions at the input image data. And so they are developing the methods which are fast and mess-free algorithm where they are solving simply this diffusion equation whose solution is a specific time step solutions, and they are denoising at certain time step. See these data. So these kind of research are also being offered by RACS, and here it is a kind of another story where some groups from electrical engineering and related other team members at some universities, they are trying to make a kind of one unified kit where they could measure some very important health parameter at this instrument. For example, these are some blood related markers, heart rate, BP, etc., and they aim to use it for astronauts' health measurements. And the one more thing is that they have developed some GUI-based data acquisition analysis system so they can quickly get these markers over the phone and computer. So, and these are the communication related projects where the Somak Bhattacharya and group, they are trying to generate meta-surface based transmitter type polarizer converter and space qualified. They are trying to claim this as space qualified filters. And they are publishing several papers through this project, and these results are available there. Not only these, but some groups from local universities, state universities in Mathura, UP, they are submitting very nice project, and they got it basically and working on it. That project aims to develop a low noise amplifier which is with high gain and low noise, and they are using it for S-band RF communication therein. Not limited to only these things, but there are several projects which are being run and executed by professors. Professor Rajendra Prasad is here, and Dr. Prasant Kumar Srivastava from BHU. They are doing some remote sensing experiments. They are using SAR satellite data from ISRO, and they are trying to understand various remote sensing applications. Similarly, Dr. Sisir Gaur, who is the coordinator of RAC at IIT BHU also, with Anurag Gauri and Prasant Srivastava and other members from SAC. They are trying to learn about the water quality monitoring using ground instrumentation and optical sensor, using airborne, ground-based sensors and satellite data, and so on. This is the last one, the last example. We are also pursuing some projects which are belonging to my group basically under this program, where we are trying to understand the physics of our sun and its atmosphere, and science objective of these projects and associated results are very much aligning with the science objective of Aditya L1 mission. I'm the part of SUIT science team also, and in this project we are trying to work recently with Dr. K. Sankar Subramaniam and Dr. TDP Srikar at URSC. The Helios and Solex X-ray observations from Aditya L1, and we are trying to understand the quasi-periodic pulsations and how these quasi-periodic pulsations can be used to probe the in situ plasma conditions at the solar flaring regions. So this project is in the third cycle, and we got very positive referee report.
Go faster, sir.
And this is basically the project which is related to Aditya L1 mission there. So this is my final slide. You can see this is the summary. So RAC IIT BHU, which is existing in less than 5 years, is doing the job there in the central region of India. We are promoting the space science mandates in central region of India. Publications are coming out in peer-reviewed journals. Technology demonstrations and softwares are being made in many projects. Apart from that, teaching, training, and outreach is the mandatory program associated with these projects. And the most important thing is that the PIs, researchers, and their team, including students, they are bridging with the ISRO centers, and they are pursuing some required research. And one point I missed here, the projects are generating the skilled manpower and human resources, and they will be able to work ahead with the space research and in aligning with the ISRO's research mandate. Thank you very much.
Thank you. Thank you very much, sir, for giving a detailed outcome of the various projects taken up at the BHU under our racks. And also you have given the outcomes also. What are all the major things coming out of these projects? Thank you very much, sir. Nice presentation.
Thank you so much, sir, for letting us know about different development activities of RICS IIT BHU. The next presentation we will have is by Space Technology Incubation Center, STIC Manit Bhopal, and it will be delivered by Professor Savita Nima from Electrical Engineering Department, Manit Bhopal. I request you, ma'am, please come forward and deliver your presentation.
Good evening all. So we have the Space Technology Incubation Center at MANIT Bhopal, which was inaugurated in the year 2021 by then Chairman Dr. K. Sivan. And simultaneously there were two other STICs also, STIC Raurkela and STIC Nagpur. VNIT Nagpur at VNIT Nagpur, they were inaugurated. So there were three STICs inaugurated simultaneously. It was in online mode as that was the COVID period. So this is one of the picture of MOU signing ceremony of STIC MANIT. So sir, for your kind information, till date, after STIC Manit was inaugurated, Yukti Sanchita was released by ISRO, in which from Central India we have submitted around 43 number of projects. And thereafter in Respond Basket we have submitted around 12 projects. Then Research Area in Space 22, again we have submitted around 15 projects. And in Research Area in Space 23, we have submitted 12 projects. And in the Respond Basket, which was released in the year December 2024, we have submitted from Manit, because that data I don't have, how many projects have been submitted from Central India, that data I don't have, because all the projects were submitted online. So from Manit, we have submitted 28 number of projects. So out of these Yukti Sanchita 2021, we have been sanctioned 3 projects. For the first project, which is Yukti Sanchita number 337, programmable automated field deployable high frequency rainwater sampler. This project closure report has been submitted, and the PI is about to file the patent. Then this was appreciated by the mentors. Then we have a second project, which is also we are having at Manit, that is design and development of ultrasonic transducers. This is almost about to be completed. The third project is development of, this design and development of ultrasonic transducer. Dr. Bharat Modera is the PI of this. Then third project is Dr. Vilas Varudkar is the PI of this. Development of miniature pressure regulator for low flow rate application. This is also in a finishing stage. So these are the 3 projects which were sanctioned to us in the year 2021. Then because of sanction of the fund was delayed. So we have started the project late. So there is a request from STIC Manage, because I know that with every project which we are submitting, because we are from academia side, you people are working in the real world problems. So there is always a scope of improvement when we people are submitting the projects, because you are actually working on the things and we are theoretically working on, most of the time we are working theoretically on it. So I'll request all the experts who are present here from the ISRO to guide us for taking up the projects, and I assure that faculty from Central India will certainly be proving their capabilities if we are given a chance. So, and being a premier institute, one more thing is that we are having a team of students in our college. They are working on real-time problems most of the time, and many of the students, they are taking up very good kind of projects. But sometimes due to crunch of funds, they are not taking up their projects to the finishing stage. So if ISRO can provide small funding to the students who are working on real-time problems, or if ISRO thinks of that they are of their use or for some kind of social cause, their projects can be utilized, we'll highly appreciate the efforts if it is done. Because sir, we are having very good students who are working on many good problems. But due to some kind of fundings or guidance, sometimes their projects are not taking up the shape. So if you people can help us, that will be highly appreciated by us. Then one more thing is that we are submitting the projects, but most of the time we are not knowing the status, even if it is accepted or rejected. So we are waiting, we keeps on waiting. So if we are being informed that whether it is selected or accepted or rejected, it will be good for us, that we can start thinking that we have to improve upon it. This is all from Manit.
Thank you, madam. Thank you, madam, very much to give an overview of the STIC and some of the suggestions to improve the functioning of STICs in the future. Thank you very much. And so this is the end of the technical session 3. And thank you all the speakers. I request Shailendra Jain sir to very briefly summarize this session, sir.
Thank you, Paul, sir. At the end of this session, I wish to extend my sincere thanks to all the speakers as well as all the participants for their sincere attention, especially post-lunch session. So this session was really planned beautifully, starting from Nishan ji has informed about the how, when, who can participate in various research activities, whereas Professor Abhishek from IIT-BHU, he is informed that what outcome can be provided by the academic institutions. And in between, we had the presentation about the various research problem from different space centers, including Satish Dhawan Space Center on Precision Instrumentation Amplifier, launch vehicle, then hydrocarbon fuels, advanced propulsion. Madam Nandita, she focused on solar astrophysics, space and atmospheric science, planetary science, astronomy and astrophysics. Vivek Kumar ji has touched a total new area on human space flight centers, and Nand Kumar ji has informed about orbit control system, satellite attitude control. In fact, and at the end, Professor Savita, who will be the contact point for all of us in MP Chhattisgarh and Uttar Pradesh region to explore this opportunity. And I hope that academic institutions, we are ready to basically back these opportunities and contribute for the nation growth. Thank you very much.
Thank you so much, sir. We are very much grateful, and we express our gratitude to all the speakers of the technical sessions, our chair and co-chair for giving us the time and for listening all the presentations peacefully. Thank you so much, sir. Now moving ahead with the program. Next we have is a discussion section. In this section, what you will do, you will be asking questions. All the audience here, they can ask the questions to our experts, to our panelists sitting over there here, and they will be answering your questions. And it is not mandatory that you will ask questions to these experts only. You can also ask some questions to other experts who are sitting here. So we encourage your participation, or active participation. So for discussion section, I request the dignitaries, Shri G. Hari Krishnan, Director, CBPO, ISRO Headquarter, JMC Chair, Dr. M.A. Paul, Associate Director, CBPO, ISRO Headquarter, Shri S. Santosh Kumar, Deputy Division Head, VSSC, Shri P. Srinivasalu, Associate Director, NSRC, Shri Ulkesh Desai, Group Head, SSC and Member of JMC, Shri R. Santhanam, Deputy Director, IPRC, Member of JMC, and Shri Shailendra, General Manager, MCF and Member of JMC. I request you all, please come to the stage and take your seats. Please, sir. Ulkesh Desai, sir. I welcome you all, sir, in this discussion section. Now, I would request audience, faculty members, research scholars to actively participate in this session. Since the sessions were going on, due to time limit, you were not able to ask your doubts or queries. I request you can ask it now. Please start with your queries.
थैंक यू वेरी मच। आज का जो सेशन है, अभी कुछ दिन पहले कुंभ हुआ था हमारे पास में, इलाहाबाद में, प्रयागराज में। ये भी साइंटिफिक एक कुंभ ही, महाकुंभ जैसा ही है। मेरा छोटा सा क्वेश्चन था यहाँ पर। आई एम फ्रॉम दी आई एम डॉक्टर मलियस दास फ्रॉम मेडिकल यूनिवर्सिटी इंदौर। आई एम फ्रॉम दी एस्ट्रोनॉमिकल क्लब इज देयर। मेरा क्वेश्चन ये था कि यदि हमें जो किसी इसरो सेंटर में मुझे अपने स्टूडेंट्स को लेकर, फैकल्टी को लेकर यदि जाना है विजिट के लिए, एनी प्रोसीजर इज देयर? क्योंकि स्टूडेंट्स में बहुत मतलब स्पेस साइंस को जानने की और देखने की बहुत इच्छा है। थैंक यू सर।
So we are also interested to interact with the students, and but we have some commitments related to the projects and other aspects. So if you feel that something has to be done, you can just write to us, and according to the requirements and needs and what kind of where you want to visit, everything we will see, and on the basis of that we will give you a reply. So the ideal thing is to just write to us. Okay.
Thank you, sir.
We'll see that.
Thank you, sir.
Yeah, I would like to just add. National Remote Sensing Center in Hyderabad has an outreach facility. Earlier, we used to allow students to come to our work centers also, but the number of colleges, institutions, requests have increased, and it started impacting the operation. So we have a separate system. We have an outreach group now. You can write to them. Large number of schools visit schools, colleges at various levels. You can indicate to them. If they find a suitable slot, they will inform you. You can come over there. And some demonstration of equipment facilities will be there. And remotely you can also see how we are acquiring data in our Earth station, Shadnagar also. You can write to teebog@nrsc.gov.in. You can just check online.
These such facilities are available in most of the ISRO centers. Our Vikram Sarabhai Space Center in Trivandrum, they do have a good museum also there. So I think they have to register in the website, and if you write to them, they will respond to you, isn't it? Yeah, they'll respond to you, and you can take your students there.
Similarly, in Space Application Center, we have Vikram Sarabhai Space Exhibition, which is called as VSSE, So you can write to vssc@exact.isro.gov.in. All the students and faculty members are invited there. You can book a slot and you can visit the VSSC center. It is completely outside the secure area, so there is no restriction to the people coming there.
Regarding visits, you can Bangalore, we have two major centers. One is URC, our Professor UR of Satellite Center, and another one is ours, ISRO Telemetry Tracking and Command Network. We are also inviting students visit, even college or school. Even 50 or 100 numbers you can bring them. We will take them to our control center or our deep space network. That is a very good facility. We have our 32-meter antenna deep space network established. So students can see that how we are tracking our interplanetary missions and lunar missions and our Aditya mission and our low Earth orbit satellites, how we are tracking. So we will give around half an hour overview about our ISRO activities, and we will take a tour around our facilities around 1.5 hours. Then we will give a little refreshments so students can enjoy. Then they can come. So we will have sample water booster rocket also we are launching for them to students to encourage them to be happy. So then they can visit Bangalore. That is our ISTRAT. For that you can contact me, our HRD @istat.gov.in. You can send all the student details and request letter from the principal and the students list with the Aadhaar card. You can send it. So whenever our dates are available, we will give the date. You can visit that. And URC also you can contact PPG. So they are also investing that. But ISTAT we are taking care.
Namaste to all. I am Dr. Sunil, but I am SPIC coordinator at VMIT Nagpur. Not questions, but there are two suggestions which I feel will help. Because a lot of researchers approach us कि इसमें exactly क्या करना है. Problem statement तो पढ़ गया, but problem statement does not describe in too much of detail. For example, if there is something in power electronics, what is the capacity that inverter that you want to build? So there are some further details that are required, and it may not be correct to share all this in public domain. So maybe either for each problem statement, can we have a small video detailing what is expected outcome of this and what are the limitations or constraints within which the researcher is expected to work, so that will help him to formulate a strategy to attack the problem and suggest a suitable methodology. Secondly, if and that video can be shared by email, or if in case that also can be done, that a particular subject matter in the subject, if it is said problem statement is video, if sent an email to directly the coordinator of the lab, it should automatically send it the video. So that will solve major problems that they have, questions, because not many times the scientists are available on phone or they are busy in their work, so they take some time to respond. So that is one suggestion. And secondly, as Niman has said, can we have an online system of status where that is available in DST and all? And perhaps here we can help our students can make that for you. Thank you.
Yeah, I will respond to that. Actually, that if you see the research areas in space document released today, so we have taken the input from almost 16 centers of ISRO. And in all these 16 centers, we have got a response coordinator and a response review team also. So these response coordinator details are also given there. So if you have identified some problem, if you wanted to have some additional information on that, you can rightly, before submitting the proposal itself, you can even write to the response coordinator, this is the type, this is the problem we are interested, we would like to have some more discussion on this topic, and they will identify the concerned person in that center. They will definitely come for a video conference with you, and you can have discussion. Whatever you want to discuss, or whatever the deliverables, etc., definitely you can discuss and fine-tune your proposal. But video making for all the themes may not be that feasible. But okay, in the future, I don't know whether sometimes we may do it also. It's a good suggestion. We will see. But time being, you can contact the response coordinator, and they will arrange whatever further discussion is required for the submission of this proposal. What was the next question? Status, yeah. Now, as of now, only respond projects are submitted online, and the status is also updated online. So, for this financial year, within a few months' time, we are planning to make all the programs of ISRO online. So, I think this will be addressed in a short course of time.
Sir, can I?
Yeah, you can ask.
Good evening, sir. Myself, Dr. Mithavarun Sharkar. I am from NIT Agartala. I am STIC coordinator over there. And first of all, I would like to thank all of you. It was a great session. I came to know so many things from you. Just I have one technical question, that was given by Srinivasulu sir during his remote sensing related presentations. Sir was talking about that satellites are being used for earthquake early monitoring system or prediction mechanism, something like that. But I don't have much idea about how satellites are giving accurate representations going on. But I came to know that it can give the data or the information, say, from the ground level up to normally 2 meters or something like that. Right now we are engaging with STIC project that was given by NISAC to monitor the, not earthquake, the landslide detection system. We are in the process. So there we got the 3 lakhs of data from NISAC. That is given only the weather monitoring systems and all these things. But I need, sir, poor water pressures. Okay, poor water pressures, that value. So that for that I have to put my system. We are actually developing this, and its prototype has already been ready. 5 meters below the Earth's surface. So this is only for the landslide. So in that case, how that remote sensing data could help us for that is in general question for me, because I know that 2 meters.
Yeah.
Thank you, sir.
In my presentation, I categorically stated as of now there is no technique available to identify the earthquakes. I made it very clear. Now you are asking, you want to identify suitable locations where you would like to keep your sensors a few meters below the surface. Is that your question? This is some instrumentation, but I think I am not getting your question.
I think you will explain.
See, one thing I would like to share is there is an interferometric SAR mode. Okay, so what we have done is in RSAT 1A, which is already in orbit. So if you have a repeat pass interferometry, so if you go for a repeat pass interferometry, you can know the ground subsidence levels. For example, if you have a 17 days repeativity, so once we have a pass on one particular day at one particular time, after 17 days, the exact same satellite will cover the same area. Comparing these two data sets, we can have the interferometer. And by interferometry, we can show the change or the subsidence level, if there is any. Similar studies have already been done in the Himalayan region, where there is a lot of subsidence, ground subsidence. The next satellite which is going to be launched is the NISR. NISR has an interferometric SAR mode. Okay, and it is going to be done in L-band. So L-band has a good amount of penetration depth. So it is a product which is going to be a global product for interferometry, which can not predict earthquakes, but it can at least detect the subsidence level once an earthquake occurs. And if you have a time series or a temporal data, maybe if you can study the dynamics, we can predict Earth, but it is just in theoretical.
Next questions.
Hello. What is the scope of environmental engineering student for applying the project? Environment.
Also, there are a lot of opportunities. If you see our research areas space document, there is a weather and climate. There is one section is there. There you will get a lot of topics of your interest definitely. And also then agriculture is another one. Agriculture related projects are there. Then even geology related also. All then mining. All these are related to environment. There's a lot of, yeah, definitely if you go through your research areas in space document, definitely you will find some topics related to environment.
You can also visit analysis, NICES, one website is there, which provides a lot of environment related products. You can visit that site also. Some more information you will get there.
Sir, myself, Dr. Jitin Kumar Tandikar, and actually I am working in a multi-level inverter and converter. So, so many powers are required. I mean, different power sources we are using in the that rocket or different power sources we are using. So different converter also we are using. So in the electrical point of view, we are using a renewable energy sources. So what kind of converters are using in that project? So we can plan, and of course, sir has said in a problem statement that was not clear. So as a researcher, how can we means what kind of actually converter they are using and what special things they are using. So if that will be clear, if it is clear to us, so we can plan to submit up some kind of project. So that gaps are there. So if we are clear that gaps, so we can plan to submit that kind of project as well. Thanks.
That has been already answered, that this action has been noted by our teams, and right now Paul also has told you how to approach the concerned domain experts so as to throw more light on the problem definition. We were also discussing among ourselves also. That's why if you note in my presentation also I was trying to give more closer information. Some information, if you look, you are talking of power converters, I can give one example. There is one project related to satellite data acquisition where it talks of a IF matrix kind of thing, where we are talking of a pin diode based switches. There the key parameter is 60 dB or more isolation. So that parameter is sufficient for somebody in the domain to understand how to approach. Maybe wherever this application related to power converter is there, you should find that information. If it is not there, please approach that center, they will tell you. Because they need to at least give you the key spec, what they are looking for you to try to design something.
Good evening, sir. I am Dr. Preeti Jain from Jabalpur Engineering College. Sir, first of all, I would like to thank and congratulate all ISRO correspondents and our STIC coordinator, Dr. Savita Nima Madam, for introducing with space research technology, and all the presentations were very remarkable. Thank you, thanks a lot. Sir, my question is like some problem statement related to microgravity or zero gravity were discussed. Sir, how we can have this type of environment at our STIC or at our places? For that, how we can deal with those problems unless and until we have that type of environment?
Okay, microgravity, this is, how to conduct the experiments in microgravity.
Exactly.
Yeah. There are many ways. Okay, I think
Direct answer to your question is if it has to be in microgravity, it has to go to microgravity. So we have a lot of collaborations, internationally. So whenever any collaboration with NASA or ESA is happening, there is an announcement of opportunity where the experiments are getting selected. And they are undergoing, if it is a long term, then they will be remaining on ISS. Or if it is going to fly in our Gaganyaan, we will be taking up in our missions.
No, I am just asking, like, we are having such type of facility in other research centers.
Yeah, on Earth we cannot create a microgravity environment for much time, as I told, on the ground based. Maximum 20 seconds you can have, feel that if that duration is enough for your input, it is fine. Otherwise, it has to go to the space only.
Yeah, actually we have this PS post pen stage, that is the final stage. We have an experimental platform which is called POEM, wherein through the in-space mechanism we have an autonomous body called in-space. In-space will be hand-holding all the private enterprises and also the education institution to have experiments on board POEM. So in that, if you are having a very good understanding of what is the kind of experiment you are going to do and what is the proposal, probably you can approach in space and based on the merit of the proposal and what is your requirement and whether they can accommodate that thing. On the basis of that, it can be accommodated as a part of POEM. So that's the ideal way in which you can, maybe realistic way, you will get the microgravity condition for a longer duration, maybe up to 1 week or 10 days or 14 days, you can run the experiment. So that will give you a very meaningful outcome. So everything depends on the kind of experiment you want to conduct. So that should be clear, what is the project that you want to do. If that is clear, then there is a way of engaging with ISRO. Yes.
Thank you, sir. Also, there is one suggestion from my side, like we are teaching student subjects like applied physics and applied chemistry, right from first semester onwards. There is a need of reframing or redesigning the syllabus so that some of these, at least problem statement can be incorporated in syllabus itself, so that student will get introduced to these problems.
Yeah, as per the NEP also, our in-space has come up with some minor courses which is now getting adopted in IIT Chennai and other places. So probably that you can look into that and you can see whether those things can be adopted in your cases.
Exactly, sir. Thank you, sir.
Since a long time to ask the question. Please, sir.
I am Sanjay Sharma, heading the Department of Electronics at UIT RGPP, that is the Technical University of Madhya Pradesh. The basic limitation with academics and students is the fund. And ideas can be from anywhere. And our students are very good in academics and giving ideas. But being academics, we are having very, not very high-end equipment in the labs. And we ask management, they will say, oh, it is not required because it is not in the syllabus and all these things. So I request all ISRO people, whether STIC or other RAC centers, can equip with the high-end, very precise or accurate equipment, so that we can go for the picosecond or microsecond level. Otherwise, it is not possible to test or to have prototype in the lab which are meant for the student in the academic institutions. So that is limitation with us. Otherwise, even I tried one project, but we are not having the facility to test that. Means very low level, precise measurement. So if you can have some setup at different STIC or RAC, that will be useful for the surrounding colleges and institutions. So this is the suggestion. Thank you.
Equipment survey, we are, as per the norms, we are supporting. So whatever minimum or whatever equipment is required for carrying out that particular project, if you can project it under the project head itself, I think we are supporting it. We have not never told no for the equipment. And as per the norms, after the once the project is completed, we can take it back, but we are not doing it. In most of the cases, we are donating it to the institute also for its further research. So I think it is there is no problem. We can project it in the project itself. Equipment also we are giving it.
Hello sir, I am Dr. Sandeep Dale. So in various research problems which that have been shared, usually what happens in academics is that whenever some problem is there, there is some prior publications are there, one can refer to that. So I'd like to know that whatever problems have been given to us, what has happened in the back at the ISRO, where any kind of publication is there when we can refer to know what is its, how historically that problem has evolved, or what work has been done in that problem, so that we can add further on. So such kind of publications there or any materials there?
No, what we meant is the PA, if he is already working in that particular field, and if the related field also, if you have got some publication in the related field also, that will help you to get the project, not the ISRO publications. Okay, so if you are working in subterranean domain and if you have got some publication, and if that project what you have projected is also related to that topic, then there is more possibility of getting that project approved. That is what you meant.
I wanted to know that, let's say one problem is there. What has happened at ISRO on that problem? What kind of research has already taken place on that particular problem at ISRO? So how to know that? Whether whatever research being done at ISRO, is this lead to some kind of publications?
Okay. In our libraries, we have a compendium of the research publications made by our scientists. That is available individually.
I can add, what happens is in some of the problems there will be multiple approaches possible for the solution. So our teams might be choosing one of the approach and they will be trying, but since for want of time or manpower, they would like academia to work on the alternate approaches. The moment you get in touch with the domain expert, whoever has given the co-PA from the centers, when that debriefing, you will come to know what they have been doing, at what status they are, why they want to you to try a different approach, or want you to continue with the same approach with some additional parameters into consideration. That only through that interaction only you will get. Please note that it is not possible for them to list out all this into multiple documents and upload. They only just give the problem definition and they will be going ahead already solving it on their own, because there is no guarantee that we will receive proposals in every problem that is listed in the book.
Okay.
So notwithstanding that, they will be continuing to work. So your interaction is the key. If you have any problem in that, then you should go to ISRO headquarters.
Okay, sir.
Data that NRSC provide means we are from a private academic institute, and getting the NRSC data is difficult for us, means like high resolution satellite data. So sir, any possibilities, means we are in this environment today that
nowadays with the new geospatial policy, a lot of data, especially 5 meter and above, Coursera is free, it is available. I don't think you have logged in. Please log into Bhunidhi website of NRSC. You can download the data. Earlier we used to have this problem of satellite data procurement in the country because it was governed through a set of procedure wherein you will have to go through NRSC. Because of prolonged delays, because back end we have to take many approvals, that has been dispensed with. Now you will be buying data through NCL. You only have to log in online and register your data.
That we are using, but sir, I am asking about little high resolution data, high spatial resolution data.
High spatial resolution data, if it is available from our IRS satellites, you will, once you log in, you will get it from our end. If we don't have that resolution, it is only a foreign source that goes through a different mechanism.
Not from Cartosat we are getting, but most recent data we are not getting.
Yeah, there could be one reason. Please understand, see, whenever you are asking data, you may be willing to pay money for it. But already there may be customers asked for some other data. See, you don't get to repeat a particular site from the satellite until certain number of days.
Yes, sir.
So if that opportunity is lost, they won't commit it to you immediately. That is where you will find sometimes delays. Non-availability of data. Sometimes higher resolution data will be largely taken by another customer of a more importance at a national level. Sometimes more time will be committed for them. Then also you will find it difficult.
Because, sir, one problem statement I have seen is urban mapping. And I think government have launched a recent project, Naksha, Government Land Record, Department of Land Record. So I think the high resolution data is in much demand now, sir. So
Some more satellites have to be launched. ISRO is as a manifest. Unless that comes with one satellite high resolution, it can't serve. Because the higher and higher resolution satellite becomes, the swath becomes much narrower.
Yes, sir.
So naturally, what we can collect itself will be very small.
Thank you, sir.
High resolution data, of course, is not available, but there is another website called as Mosdak and Vedas, which is hosted by SAC. Lot of data is available, but as sir said, above 5 meter. Less than 5 meter data is not openly available.
Any more questions?
Yes, yes, sir. See, why Navik is not being used, like why we are not exploring so much with Navik? Why everybody is using NASA's GPS?
Actually, Navik, basically the constellation is not yet complete. Okay, so we are having some upcoming launches in the next 1 or 1.5 year. So once the constellation is complete, I think it will be available.
Okay.
Navik enabled L1 and L5 NS bands. So
Like,
slowly it will come.
sir, for wide monitoring of our system, now we have started using PMU, Phasor Measurement Unit. That is also using that NASA's GPS for getting timestamp that data and all. So there is a lot of risk of spoofing attack and all with that data, and that we are seeing in war condition also.
Madam, basically what we do is, the space segment is what is ISRO's responsibility.
Yes.
Ground segment, we have left to the Indian industries to make their devices and proliferate.
Okay, sir. But that is also a very crucial issue, like for monitoring our power system and all.
Yeah, I understand that this particular point, you can have one discussion probably, because so many people are waiting there, and we will take the next question and we will
Okay,
close it.
thanks.
Next question. Next question. Anybody?
Hello sir, I am Dr. Sachin Saxena from IIIT Jabalpur. Sir, it is heard that once a ISRO project is completed, I think through the Respond Basket, the facility or the research created by the BI is taken back by the ISRO. Please correct me if it is wrong.
We have not taken, till now we have not taken back anything so far. Only the deliverables you have to give. Whatever product or whatever the deliverables of the project, that you have to give it. But as per the norms, if we want, we can take it back. But so far we have not taken it back, any of the equipment or whatever facilities set up there, we have not taken it back so far.
Thank you, sir.
Any more questions? Any more questions?
Sir, actually I am Jayan from Smart Manufacturing. Sir, I am working in the area of additive manufacturing. Actually, we know the basics and we have done research in basic science only. But whatever problem you are giving, it is like particular thing. So how to approach towards that? Like,
these are all specialized problems, no? In my opinion, it will be better if you can have discussion with the PA who is handling this. You will get better clarity on what is the definition he is looking at and what is the outcome that he is expecting from the people who are going to take the project. So that will be the best course of action for you. Since you are looking at a very specific area, no? That will be the best option.
Thank you.
Thank you.
So regarding, sir was asking information about the students, what we suggest is, once your project is approved either STAC or RAC, please send your students, those who are involved, either 1 week or 2 weeks, you send to the respective our centers. So you are in the academia, so we are in the practical. So madam also is telling how to solve the problem, what are the things. So all the things will be there with our library, all the documents are there. Whatever the previous students, what are done, the projects also well documented and it is available. So they can refer to that and get an idea, better idea also. So better you can, universities can allow them, so either 1 week or 2 weeks, so Akin with our guide, so they can get better idea, so they can go ahead with us. So library they can use it, all the documents are there, they can read it, but they cannot take it out. That's all.
hello. Sir, myself Dr. Pankaj Kumar and I am from CSE department. I am working on a security field for wireless communication. So basically I design an authentication protocol for wireless technology so that we can ensure, so whatever we are sharing the data through public channel or wireless channel, so we can say the data is secure. So I want to write some proposal for satellite communication. Whatever data is sharing or receiving the data from satellite, how can we ensure that that data is authentic? Means maybe some not authentic satellite that is launched by some another country, so that satellite can also send the data, same data. So how can we ensure that that data is not malicious data? So I want to work on that field. So how can I approach for this types of proposal? Because data authenticity is most important thing. Before going to perform any kind of action on that received data, so
basically data will not come directly as bits and bytes, it is encoded.
It is
highly encrypted and it comes. So it is not easy to crack the code.
So
what you are talking wireless communication is using ZigBee or something for a short distance. What you are talking is from a very high altitude. And there are a lot of encryptions and each key gets changed periodically.
So whatever data is receiving is done by the some encryption technique. So maybe that encryption can be exploited.
Yeah,
Maybe
you
that
can
approach.
find out the new methods of encryption and you can suggest.
I want to work and I know the best methodology that can take relatively less cost as compared to the existing one. So I just want to propose some proposal.
No, is it only coding methodology or the hardware corresponding to that also?
Only software based. Maybe I'll work on a hardware based setup.
Some modulation techniques?
Not till now I didn't do on the hardware setup because I don't have a lab. Recently I joined in the Department of Computer Science. So maybe first of all I have to set up the lab, then I can perform these types of activities.
Yeah, good code is always desired. You can always propose it. Because the transmission of data is also expensive.
Because lightweight encryption techniques I have. And I am working on lightweight authentication and lightweight encryption and decryption techniques. So maybe the existing techniques taking lots of computation cost and less reliable.
RF or optical?
Huh?
You are talking in RF domain or optical domain? Security.
Security domain.
And that is in RF range or optical, like laser based?
No, not laser based, only
RF.
yes.
Yeah, you can always suggest that. It is always desired to have different.
So how can I approach for this types of project or proposal?
See, in general terms, we can defend that, but if you are very specific about that, whether it is available in our document, whether you have gone through the document, whether it is available, a topic is available.
Yes, sir. Sir,
if the topic is available, then there will be a PA who is identified. You have to write to the PA. He will be the specialist person who is handling this particular issue, and then he will be able to give a proper input on that.
sir, I have read lots of research paper based on this satellite communication, but that paper suffers from some.
No, I understood the question, but in a generalized way, it is put in the research area in space document. So in case you have some specific, you can kindly write to that person.
Yes.
He will be the PA who is addressing this issue, and he will definitely give you a feedback. In case you are facing some problems, you can always reach out to us. Our email ID is also given in the document. Okay,
Thank you, sir.
Thank you, everyone. And if any questions are remaining, you can ask it in the dinner time. So we will close our discussion section. Thank you to all our dignitaries for answering the questions, and first of all, thank you to the participants for an effective and interactive session. This was very good from both the sides. Thank you. Next. So please receive. We are grateful and thankful to all the dignitaries and speakers. We would like to acknowledge them with memento as a token of respect and gratitude. For this, I would request Dr. Shailen Jain, sir, first of all, to acknowledge Shri G. Hari Krishnan, sir, Director, CBPO, ISRO Headquarters. Sir, please, sir. Second, I would request Shri G. Hari Krishnan, sir, to provide a memento to Dr. Savita Nima, ma'am, Coordinator STIC. Now, again, I would request Dr. Shailen Jain, sir, to present a memento to Dr. M.A. Paul, Associate Director, CBPO, ISRO Headquarters. Next, I would request Dr. Shailen Jain, sir, to provide, now I would request Dr. Nima, sir, to provide a memento to Shri P. Srinivasu, Associate Director, NRSC. Please give a round of applause for them. Now, I would again request Nima, sir, to provide a memento to Shri Nishant Kumar, Deputy Director, CBPO, ISRO Headquarters. Now, I would request Professor Savita Nima, ma'am, to present a memento to Ms. Nirupama Tiwari, Deputy Director, CBPO, ISRO Headquarters. Now, I would again request Savita Nima, ma'am, to provide a memento to Shri R. Santhanam, Deputy Director, IPRC. Now, I would request Professor Shailen Jain, sir, to present a memento to Shri Now, I would request Dr. Priyanka Paliwal, ma'am, to present a memento to Shri C. Pradeep Kumar, Group Director, ISTRAC. Okay, he is left. Okay, sir, I will take on behalf of him. Now I would request Dr. Pankaj Sonkar to provide a memento to Shri Javed Sar Qureshi, Group Director, MCF. Next, I would request Dr. Suresh Gavre to provide a memento to Shri KVS Bhaskar, Program Director, URSC. Now, I would request Dr. Shalin Jain sir to present a memento to Shri S. Santosh Kumar, Deputy Division Head, Vikram Sarabhai Space Center. Vilas sir will provide a memento. Next, I would again request Dr. R. K. Nima sir to provide a memento to Shri Vivek Kumar Khare, Division Head, HSFC. Next, I would request Professor Savita Nima Madam to present a memento to Shri Ulkesh Desai, Group Head, SSC. Now, I will request Dr. Pankaj Sonkar sir to provide a memento to Professor Abhishek Kumar, IIT BHU. Now I will request Dr. Shalin Jain sir to provide a memento to Shri P. Srijit, Scientist Engineer, SF LPSC. Now, I would request Dr. Suresh Kumar Gavre to present a memento to Shri Shankar Madaswamy, ISRO. Next, I would request Dr. Vilas Kumar to present a memento to Shri Shailendra Kumar, ISRO. Next, I would request Shri G. Hari Krishnan sir to present a memento to Dr. Shailendra Jain sir, co-chair, manage. Yes, sir. Next, I would request Dr. P. Srinivaslu sir to present a memento to Dr. K.K. Dhote, co-chair, manage. I think he is not here. So this was all for our mementos, for our acknowledgement session. Thank you to all the dignitaries, over here from Managed side as well as from ISRO side. Thank you once and all.
I request all students and faculties, please visit, plan visit to our ISRO centers. So you will get a good feel. Especially welcome to our ISRO, where the Prime Minister visited 3 times, and the Chandrayaan 3 was controlled from our center only. So you will feel for that. Please visit to our centers. Thank you.
Now we have the cultural program here itself, and STIC hall is also open. If anyone who wants to visit, they can. It is open for visit.
We came to the last portion of our today's program. So before that, I would request Shri Nishant sir to give a vote of thanks for the technical sessions.
A very good evening to all. We know it is getting late and it is late evening, but it is never late to acknowledge all the persons who have contributed for this technical session workshop. We have this one-day ISRO Academia Connect. So first of all, I would like to say thanks to our Secretary, Department of Space, Chairman ISRO, Dr. V. Narayanan sir, and when we have put up the proposal that we want to have to conduct this, sir was very positive and it was approved. Even though sir was traveling, but he could be able to accommodate our inaugural session in changing times and we could be able to go ahead. So thanks to Secretary sir. Then we would like to thank Director Maulana Azad National Institute of Technology, Dr. K.K. Sukla sir for hosting us and giving to conduct this wonderful academia connect at our MNIT campus for Central Region. The preparation was almost on from last 1 or 2 years. Lot of human resources and other things, supports are required, approvals are required, and it has been given. I would like to thank Scientific Secretary M.N.S. Pillai sir for his consistent support. Director CBPO, Sri Hari Krishnan sir, he was traveling and he came yesterday especially to see that everything should run smoothly and reviewed the progress and guided us from the beginning. Associate Director CBPO and our CBPO team members, few of them are here and few of them are supporting from the back end at ISRO labs and as well as from RSC Kolkata where Chairman was there. So thanks to all. I would like to say this was an action of joint committee meeting to we have to conduct a ISRO Academia Connect here. Last joint committee meeting when it was conducted some 4 or 5 months back. And all the joint committee members, most of them have come here in person. I know most of them have reached, all the speakers have reached late night, their flight was delayed and they reached almost midnight or early morning, 12 o'clock, 1 o'clock, but they are still, when they reach here, they are on time with all the presentation and all these things. So we would like to express our sincere gratitude and thanks to all the speakers, all the joint committee members. Further, I would like to say one small thing. It was not only ISRO Academia Connect. We have inaugural of STIC, Space Technology Innovation Center. And the last milestone activity was going on at the last things, some of the last batch of work and last work was going on like curtains, some cleaning and all the arrangements and other things, which was last 2 days because we cannot inaugurate until it is fully functional. I request all of you who are staying there, you can just see it. So it has been ensured that it has been done and it has been done by support of HOD Electrical Engineering Department, Professor Sushma Gupta and our STIC coordinator, Professor Savita Nema and all the faculty members and students. So thanks to all. Thank you to all STIC, STC, RSCS coordinators who have came from all the way from different parts of the country, from the Tripura to IIT, to all the corners of the country. They have came and they took the pain if they should attend here. Thank you very much. To the organizing team members of MNIT, they have left no stone unturned and met all the requirements and could be able to do this job wonderfully. Thank you to all. At last, the PhD scholars, they have been, I am seeing their struggles from last 2 days and I understand it's more difficult than to convert a code or conduct some experiment within a short time. It has to be done in time frame, which is not their domain skill. It is different, diverse sort of things. So thanks to all the members. I cannot take the name of all, but I know many of you and we will remain connected. So thanks to all the scholars and students. Thanks to media, transport, canteen, supporting staff, and at last the participants who came from all the way and at 6 o'clock, 6:30 after listening to 16, 17 different topics on highly different range, still they have a lot of questions. So thanks to all the participants and our counterpart, Professor Saitanya ma'am, thanks to making all the wonderful arrangement. We will see that how STIC can progress further. We request during dinner time, the members who are going, you can visit, it is walking distance at STIC facility. And those who are staying MC member, we can further interact and see how we can improve it. Thank you. Bye. Jai. Thank you to our anchors also. Thank you.
So, the last segment of today's program is a cultural presentation, Rhythms of Grace, where you will be witness of a splendid Kathak dance performance presented by Puru Kathak Nritya Academy. I request the group to come on the stage and proceed with the performance. Okay, you have to wait for 2 minutes.
एक सेकंड लैपटॉप है क्या?
इसके अंदर रख देना चार्जर चार्जर
पोडियम नहीं हट पाएगा क्या? ये बोल रहे पोडियम हटाने के लिए हट जाएगा? ठीक है।
ये रीड नहीं कर रहा है इसमें।
बिना चार्जर के नहीं चलेगा।
मैम चार्जर इंटरप्ट करा बीच में इसको।
कौन सा? नरेश पता नहीं लेके आना वाले थे क्या? तो रहने दो, वो चाहिए हम लोग उसी के लैपटॉप में चला दिए। हम लोग सोचा कि लैपटॉप में चला दी, छोड़ दो। I think 1 hour. Only one Kathak dance, but for one Kathak dance. After that,
पूछो अभी ये तो यहाँ कोई है नहीं, अपन ही है तो एग्जिट कर देते हैं। निशान सर वहाँ है बाहर के।
वो तो वहाँ चलेगा। एक्सेप्ट कर ये तो वहाँ भी तो दिखाएंगे कि वहाँ ऑनलाइन है क्या कोई अभी?
कोई नहीं है। कत्थक देखने में बड़े लोग हैं। नहीं कल्चरल के लिए
निशान सर
जो ऑफलाइन है
सर
यस हम पेन ड्राइव दे रहे हैं।
सर एक्सक्यूज मी सर कैन वी मीन्स ऑफलाइन ऑनलाइन सेशन को बंद कर दें? बंद कर हाँ जी 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 कैसे बंद कर दो।
चल रहा है क्या?
जरूरत नहीं है।
हेलो हेलो
दीदी माइक की जरूरत पड़ेगी सब ये रखिए। पोडियम को हटा दीजिए। फिर कहाँ से बोल उस तरफ से बोल सकते हैं क्या? नंबर ही नहीं है माइक में, आपको ये दे दूंगा। किनारे कर लेंगे अपन।
हाँ
सविता जी भी हमने मैडम ये वाली लाइन को बुला
इवेंट है उन्हीं के STIC कोऑर्डिनेट हो रहा है ना, उनको ISRO का कंबाइन इवेंट है उनको ये आप लोग का क्या बाकी है इसमें? क्या सर और क्या बाकी है इसमें?
एक बार ये चेक कर लो।
कुछ बाकी नहीं, बस साउंड चेक करना। अच्छा क्या सर ये पूरा बजेगा क्या? पूरा बजा मैंने पूरा प्ले करना है? पूरा नहीं, एक एक सॉन्ग है। एक एक सॉन्ग है, आप ही लोग प्ले करेंगे? ओके 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 ठीक। लैपटॉप पर तो पता है वो लोग कर देंगे। हाँ बैटरी फुल हो। चार्जर के पास चार्जर दे दो कहीं हो जाए। हाँ अभी यही वहाँ रख देते बैक कर चलो। वो बैग रख के नहीं है अपने लैपटॉप का। पूछो लैपटॉप बैग कहाँ रखी है? तो इस लैपटॉप से पक्का तो ये डाल दो इसके बैग में। जान मुझे लगा
ये जो साउंड ये देख रहे हैं इनका नाम क्या?
अनस जी अब जानते हैं सर सिविल में, अच्छा स्टिक मैके वाला में, अच्छा मैम आप सेट है, साउंड चेक करना, ओके चलिए एक बार चेक कर लेते हैं। हो जाएगा कुछ स्टार्ट कर देते हैं। अरे कोई सर एक सीक्वेंस बता दीजिए फिर स्टार्ट करते हैं। सर वही ऑपरेट कर लेंगे फिर हम आप यही रहेंगे ना ऑपरेट करने के लिए, बिकॉज नहीं तो इसको ऑपरेट कौन, हाँ क्योंकि हम आप बैठ स्टार्ट करें फाइनल। Sorry for the delay. Sorry for the delay. So finally we are going to start the dance performance. So welcome them with a big round of applause.
नमस्कार। आप लोग विचार मन में वैज्ञानिक विचार मन में रहे होंगे, थोड़े से सुखी पल इस वक्त कथक आप लोगों के लिए पेश है। ये पूर्व कथक अकादमी की ओर से और आज की शाम 4-5 प्रस्तुतियां रहेंगी आपके लिए, थोड़ा सा कम दिया है क्योंकि देर हो गई है। तो आप कथक से थोड़ा सा रुक आते हैं कि कथक आप जानते हैं कि उत्तर भारत की प्रमुख शास्त्रीय नृत्य शैली है जिसका मूल अर्थ है कहानी कहने वाला। यह नृत्य शैली कथावाचन, अभिनय और भाव प्रदर्शन का अनूठा संगम है। कथक के 3 मूल तत्व होते हैं, नृत्य यानी मूवमेंट, नृत्य यानी प्योर डांस एंड नाट्य, 3 हिस्से कथक के। और कथक का उद्भव मंदिरों में कथावाचन से हुआ, जहाँ कथक समुदाय के लोग भगवान की कथाएं नृत्य के माध्यम से प्रस्तुत करते हैं। मुगल काल में यह दरबारों में पहुंचा, जहाँ इसमें सौंदर्य, श्रृंगार, नजाकत और बारीक अदाओं का समावेश हुआ। यह शैली हिंदू और इस्लामी सांस्कृतिक प्रभावों का सुंदर संगम मानी जाती है। और आज कथक जो है वो हमारी हिंदी फिल्मों में बहुत लोकप्रिय है। जो भी आप जो बड़े डांस नंबर सुनेंगे देखेंगे उसमें कथक कहीं न कहीं समावेश रहता है। कथक के मुख्यतः 3 घराने हैं, लखनऊ घराना, जयपुर घराना, बनारस घराना। और हम लोग मध्य प्रदेश में हैं तो पिछले करीब 40 साल से एक और घराने को मान्यता मिली जो रायगढ़ घराना, लेकिन रायगढ़ छत्तीसगढ़ में हो गया। तो कुल मिला के 4 घराने, चारों की थोड़ी विशेषताएं, इतने डिटेल में जाने की जरूरत नहीं। और अब हम आपको परिचय दे दें जो कथक अकादमी की संचालिका हैं क्षमा मालवीय जी। क्षमा जी मध्य प्रदेश की कथक नृत्यांगना, नृत्य निर्देशिका एवं शिक्षिका हैं। इन्होंने इंदिरा कला संगीत महाविद्यालय खैरा से कथक नृत्य में स्नातकोत्तर उपाधि प्राप्त की है। क्षमा ने अपनी नृत्य शिक्षा पद्मश्री डॉक्टर से प्राप्त की। खजुराहो नृत्य समारोह, विश्व दिवस मॉरिशस, संगना संगीत नाटक अकादमी दिल्ली, केरला कथक उत्सव आदि अनेक समारोहों में आपने नृत्य प्रस्तुतियां और नृत्य निर्देशन किया है। इन्हें समाज का गौरव सम्मान और नारी प्रतिष्ठा सम्मान भी प्राप्त है। अब कथक के आप बात हो और शिव की आराधना न हो, ऐसा हो नहीं सकता। कथक नृत्य में शिव स्तुति एक अत्यंत प्रभावशाली और भावपूर्ण प्रस्तुति होती है। शिव को नटराज यानी नृत्य के देवता के रूप में पूजा जाता है और इसका तांडव स्वरूप नृत्य की शक्ति, सृजन और संहार का प्रतीक है। कथक में शिव स्तुति न केवल भक्ति का प्रदर्शन होती है बल्कि लय, ताल और अभिव्यक्ति का भी उत्कर्ष होती है। शिवांगिकम एक कथक प्रस्तुति है जिसे पेश कर रही हैं विजेता जैन, भूमिका जौहरी और अन्वेषिता सिंह। इसमें भगवान शिव नटराज के रूप में अपने दिव्य तांडव द्वारा सृजन, संरक्षण और संहार की ब्रह्मांडी लय को प्रकट करते हैं। उनका अंगिकम शरीर की गति और मुद्राएं
गति और स्थिरता के अद्भुत संतुलन को दर्शाता है। यह संतुलन कथक नृत्य में योग, ऊर्जा, आध्यात्मिकता की अनुभूति कराता है, जहाँ हर चक्र, हर ठहराव शिव से जुड़ाव का माध्यम बनता है। प्रस्तुत है शिवांगिकम।
दरअसल कोई भी स्टेज पे कार्यक्रम के पहले, खासतौर से ग्रुप डांस के पहले थोड़ा वक्त चाहिए होता है, करीब आधे घंटे का स्टेज को मार्किंग करने का, फॉर्मेशन करने का। वो अभी नहीं मिल पाया, तो यदि थोड़ी बहुत चूक इन बच्चों से हो तो माफ करिएगा। संगीत नर्तन कथक की एक दुर्लभ विधा है। क्षमा करें, किसी की आवाज बहुत जोर से आ रही है, इधर तक बच्चे भी कह रहे हैं, तो थोड़ा सा प्लीज। कथक नृत्य की प्राचीन परंपरा में नृत्य संगीत का विशेष स्थान है, जिसमें नृत्य के बोलों को न केवल प्रस्तुत किया जाता है बल्कि गाया भी जाता है। यह परंपरा विशेष रूप से ब्रज की रासलीलाओं में देखने को मिलती है और कथक लखनऊ घराने में भी इसे संगीत के टुकड़े या बंदिशें कहा जाता है। इसी अनुपम परंपरा को पुनर्जीवित करने के उद्देश्य से आदरणीय डॉक्टर पुरु दधीच ने यह विशेष नृत्य संगीत बंदिश रची है। इस बंदिश को राग जन सम्मोहिनी में निबद्ध किया गया है, जिसकी संगीत पर रचना डॉक्टर पूर्णिमी मगवकर द्वारा की गई है। यह प्रस्तुति 3 ताल में है, जिसमें हारमोनियम पर संगत हर्षवर्धन भट्ट, तबले पर पवन सेन और पढ़ंत डॉक्टर विभा दधीच द्वारा की गई है। यह प्रस्तुति नृत्य और संगीत के उस प्राचीन समन्वय की एक मधुर झलक है जिसमें गायन, लय और गति मिलकर एक नई सृष्टि का सृजन करते हैं। इसमें भाग लेने वाले कलाकार हैं अवनी राय, अवनी सिंह, वंशिका टेकाड़े, त्वरिता जैन, वेदिका रघुवंशी और राधिका ताम्रकार। मेरा निवेदन है कि जो पीछे व्हाइट स्क्रीन है ना, इसमें आप भले ही या तो इसको बंद कर दीजिए या जो आपकी कॉन्फ्रेंस का जो बैनर है वो ही लगा दीजिए, है ना। प्लीज व्हाइट ना दिखे, सफेद ना दिखे, मेहरबानी करके। कथक में एक और महत्वपूर्ण रचना होती है ठुमरी, और वो भी होरी ठुमरी, राग और रंग का अनूठा संगम। होरी ठुमरी होली के उल्लासपूर्ण पर्व से जुड़ी एक लोकप्रिय और मनभावन शास्त्रीय शैली है, जिसमें राधा कृष्ण के प्रेम, हास्य और शरारत की रस प्रवाहित झलक मिलती है। ठुमरी शास्त्रीय संगीत की एक सुगम और भाव प्रधान विद्या है, जो कोमलता, अनुराग और भक्ति के रंगों में डूबी रहती है। इस प्रस्तुति में राग की भावपूर्ण अभिव्यक्ति और होली के रंगों का उल्लास एक साथ झलकता है। प्रस्तुत ठुमरी ताल रूपक में निबद्ध है, जो इसकी लयात्मकता और मधुरता को और भी निखारती है। यह रचना रस और राग का वह संगम है जिसमें शास्त्रीय संगीत की गहराई और लोक उत्सव की चंचलता एकाकार होती है। इसे प्रस्तुत कर रही हैं भूमिका जौहरी, श्रेया जैन, विजेता जैन, अन्वेषिता सिंह, सानवी श्रीवास्तव, अवनी सिंह, वंशिका टेकाड़े, वेदिका रघुवंशी और त्वरिता जैन।
कान खेले कहाँ ऐसी होरी गुइया, कान खेले कहाँ ऐसी होरी गुइया, कान खेले किन रंग में गोरी मुख मली है रोरी, किन रंग में गोरी मुख मली है रोरी, राधे पूछत करी कर जोरी, राधे पूछत करी कर जोरी, कान खेले कहाँ ऐसी होरी गुइया, कान खेले कहाँ ऐसी होरी गुइया, कान खेले। साची कहो नहीं मानूंगी मोहन, साची कहो नहीं मानूंगी मोहन, ऐसी कौन सखी, ऐसी कौन सखी, ऐसी कौन सखी, रंग बोरी गुइया, कान खेले कहाँ ऐसी होरी गुइया, कान खेले। सिर चोटी गुंदाई मांग मोती भराई, सिर चोटी गुंदाई मांग मोती भराई, कर चूड़ी पिन्हाई सारी दीनी उड़ाई, कर चूड़ी पिन्हाई सारी दीनी उड़ाई, देखो आज बिंदा शाम सुंदर की खुली है कैसी जोड़ी, हो कान खेले कहाँ ऐसी होरी गुइया, कान खेले कहाँ ऐसी होरी गुइया, कान खेले, कान खेले कहाँ ऐसी होरी गुइया, कान खेले कहाँ ऐसी होरी गुइया, कान खेले कहाँ ऐसी हो ऐसी थोड़ी गुइया कान खेले। बरजोरी कर रंग डारी, बरजोरी कर रंग डारी, बरजोरी कर रंग डारी। ऐसो ढीठ लगर नहीं ऐसो ढीठ लगर ऐसो ढीठ लगर नहीं मानत अरज। बरजोरी कर रंग डारी, बरजोरी कर रंग। सगम पगम 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 गम पम पम गम गम पम पम गम पगम पगम पनी नी 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 सा 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 नि सा नि प नि पम पम गम ग स गम प सा गम प नि नि सा भरे भुजन पिचकारी ऐसी मारी, भरे भुजन पिचकारी। गम pani pani pama gama pani pani pama gama pani sare ni sani pama pa gama pani sa gama pani sa gama pani sa। भरे भुजन पिचकारी ऐसी मारी, भीज गई तन सुरंग रंग सारी, भीज गई तन भीज गई तन सुरंग रंग सारी। अपनी मौज में पकड़ लीनो, अपनी मौज में पकड़ लीनो, बहिया पकड़ मोरी चुनर पारे। बरजोरी कर रंग डारी, बरजोरी कर रंग बरजोरी कर रंग डारी। सा 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 गम प प प प प प प गम प गम प गम pani पम गम pani पम गम pani पम गम प गम प गम प गम प। बरजोरी कर रंग डारी, बरजोरी कर रंग डारी, बरजोरी कर रंग डारी। ओ दिर तानूम तानूम तारे दीन दादारे तानी तानूम तानूम तारे दीन दादारे तानी नादर दी तानी दादारे दीन दादरे ना पानी सारे नी सानी पम पगम दीन दादारे तानी तानूम तानूम तारे दीन दादारे तानी तानूम तानूम तारे दीन दादारे तानी। ओ दिर तानी दिर दिर तानी दीन ताना तेरे ना, ओ दिर तानी दिर दिर तानी दीन ताना तेरे ना। धा तेरे किट तक धुम तेरे किट तक धा तेरे किट तक तेरे ना। गम प गम प गम pani पम गम pani सारे नि सा नि पम प गम प। ओ दिर तानूम तानूम तारे दीन दादारे तानी तानूम तानूम तारे ओ दिर तानूम तानूम तारे तानूम तानूम ओ दिर तानूम तानूम ओ दिर तानूम तानूम तारे दीन।
होरी की मस्ती के बाद अब थोड़ा सा आध्यात्मिक रंग देने की कोशिश करते हैं। एक आध्यात्मिक दृष्टिकोण है सूफी या सूफियाना। सूफियाना एक इस्लामी रहस्यवादी परंपरा है जो इश्क मजाजी यानी सांसारिक प्रेम की बजाय इश्क हकीकी अर्थात ईश्वर से प्रेम में आस्था रखती है। सूफी मत के अनुसार आत्मा का सर्वोच्च उद्देश्य अपने सृजनकर्ता से मिलन है और यह मिलन प्रेम, समर्पण, सेवा और ध्यान के माध्यम से ही संभव होता है। सूफी शब्द की उत्पत्ति अरबी शब्द सूफ से मानी जाती है, जिसका अर्थ होता है ऊन, जो उन सादगी प्रिय संतों के वस्त्रों का प्रतीक था जिन्होंने भौतिक सुखों का त्याग कर दिया। सूफी संतों का विश्वास है कि ईश्वर तक पहुंचने का मार्ग प्रेम और संगीत, ध्यान और सेवा से होकर जाता है। सूफी परंपरा के संवाहक हजरत अमीर खुसरो भारतीय उपमहाद्वीप की सांस्कृतिक और आध्यात्मिक विरासत के ऐसे नायाब रत्न हैं जिनकी रचनाएं आज भी इश्क, भक्ति, संगीत और संवाद की एक जीवंत परंपरा को जीवित रखे हुए हैं। उन्हें केवल एक कवि या संगीतक कहना उनके योगदान को सीमित करना होगा। वे सूफी प्रेम और भारतीयता के सेतु थे। प्रस्तुत है भाव और भक्ति की नृत्यमयी अभिव्यक्ति, जिसे पेश कर रही हैं भूमिका जौहरी, अन्वेषिता सिंह, विजेता जैन, वेदांशी मिश्रा, याचना सोडी और सानवी श्रीवास्तव। यदि सूफियाना दर्शन आपको समझना है तो उसके लिए बहुत आसान शेर है खुसरो साहब का। खुसरो दरिया प्रेम का उल्टी वाकी धार, खुसरो दरिया प्रेम का उल्टी वाकी धार, जो उतरा सो डूब गया, जो डूबा सो पार। ये सूफियाना गजल पर आधारित कथक प्रस्तुति एक अनूठी कलात्मक अभिव्यक्ति है। भारतीय शास्त्रीय नृत्य कथक की सौंदर्यपूर्ण भंगिमाएं और लयबद्ध चाल जब सूफी संगीत के सूक्ष्म भावों से जुड़ती हैं, तब वह ऐसा अनुभव रचती है जो दर्शकों को सांसारिक सीमाओं से परे आत्मिक और दिव्य भावों की ओर ले जाता है। प्रस्तुत है नूर ए अजल यानी द एटर्नल लाइट।
जहाँ भी मैं देखूं अंधेरा बड़ा है, जहाँ भी मैं जाऊं वो रास्ता खड़ा है। हमेशा दिलों को दिलों से जो जोड़े वही एक मोहब्बत का रिश्ता बड़ा है। खुदा गुमशुदा मेरा मेरे मौला साथ दे, मेरा हाथ थाम ले, तेरा बंदा मुश्किलों में गिरा। ये अज़ल नूरे खुदा दोनों जहानों की ज़िया, आगे तो चल यही सदा रोशन करे रास्ता तेरा। मौला मन को नूर से भर दे, मौला मन को नूर से भर दे, मेरी रूह को नूर से भर दे, मेरी राह को नूर से भर दे। मौला मन को नूर से भर दे, मौला मन को नूर से भर दे। तेरे नूर ही का कमाल है जो दिखाए ना हर जगह, तेरे नूर ही का कमाल है कि चमक उठे मेरी हर दुआ। तेरा नूर ही तो जमील है, तेरा नूर ही तो करीम है, तेरा नूर ही तो गफूर है, तेरा नूर ही तो रहीम है। बस तेरा नूर, बस तेरा नूर, तेरा नूर नूर नूर। मौला मन को नूर से भर दे, मौला मन को नूर से भर दे, मेरी रूह को नूर से भर दे, मेरी नूरे खुदा हर पल रहे रोशन सदा।
आखिरी दो प्रस्तुतियां, उसमें से लय, गति और सौंदर्य की अभिव्यक्ति तराना। आमतौर पर तराना अंतिम प्रस्तुति होती है मुख्यतः कथक परफॉर्मेंस में, लेकिन एक खास आइटम आपके लिए बचा के रखा है। तो तराना कथक नृत्य की एक पारंपरिक रचना है जिसे प्रायः हिंदुस्तानी शास्त्रीय संगीत की मध्य या द्रुत लय में प्रस्तुत किया जाता है। इसमें नर्तक जटिल पदचाल, सुंदर गत, तानों और घुमावों के माध्यम से लयात्मक सौंदर्य को मूर्त रूप देते हैं। यह विशेष तराना लखनऊ घराने की विशिष्टता को दर्शाता है, जिसमें सहजता, कोमलता और सटीकता के साथ प्रस्तुतिकरण होता है। लखनऊ घराने की शैली में तराना केवल तकनीकी निपुणता का नहीं, बल्कि सौंदर्य और भाव की बारीकी अभिव्यक्ति का भी माध्यम बनता है। इस रचना में ठुमरी, दादरा और होरी जैसी गायन शैलियों की भाव रसधारा भी छाया की दृष्टि गोचर होती है, जो इसे और भी अधिक मोहक और समृद्ध बनाती है। यह प्रस्तुति नृत्य और संगीत के उस गहरे जुड़ाव को दर्शाती है जिसमें शब्द नहीं, केवल लय और गति बोलते हैं। इसको पेश कर रही हैं अवनी राय, राधिका ताम्रकार, वेदिका रघुवंशी, त्वरिता जैन और श्रेया डे।
Da
हम आभारी हैं मैनिट के, इसरो के, आप सभी के कि आपने इन बच्चियों को यहाँ मौका दिया और प्रोत्साहन किया। हम विशेष रूप से आभारी हैं सविता नेमा जी के, प्रियंका जी के और सारे स्टाफ के। मैं सबके नाम नहीं जानता, आप सब ने हमको बुलाया और ये कार्यक्रम करने का अवसर दिया। अब आज की शाम की अंतिम प्रस्तुति में आ गए हैं हम। हजरत अमीर खुसरो की एक कालजयी सूफी रचना है। देखिए, इसरो की बात हो रही है इसलिए खुसरो को लेके आए हैं कि इसरो इन खुसरो एक राइम करते हैं। और आप माने ना माने, लेकिन इसरो और खुसरो दोनों में कुछ रोचक साम्य है। यदि इसरो के वैज्ञानिक खफा ना हो तो मैं कुछ बात कहना चाहता हूं। इसरो और खुसरो दो बिल्कुल अलग क्षेत्रों के प्रतिनिधि शख्सियतें या संस्थाएं हैं। ये विज्ञान और अंतरिक्ष अनुसंधान का प्रतीक, दूसरा सूफी संगीत, काव्य और संस्कृति का। लेकिन दोनों का भारतीयता की सेवा में समर्पण है। इसरो भारत की वैज्ञानिक आत्मनिर्भरता और राष्ट्र की सेवा में प्रतिबद्ध संस्था है। सीमित संसाधनों में बड़े सपने साकार करने वाला संगठन। उधर अमीर खुसरो भारत की सांस्कृतिक आत्मा में रचा बसा कवि और संगीतक, जिन्होंने हिंदवी भाषा को गढ़ा, भारतीयता को अपनी रचनाओं में समाया। दोनों ने भारत को विश्व में अनूठी पहचान दिलाने का काम दिया, एक ने आकाश में, एक ने शब्दों में और सुरों में। खुसरो फारसी, तुर्की, हिंदी भाषाओं का मेल कर नई साहित्यिक और संगीत परंपराएं शुरू करी, जैसे कव्वाली और तराना। यहाँ तक कि जो खड़ी बोली हिंदी हम बोलते हैं वो खुसरो की ही देन है। तो आइए और बात ना करते हुए आखिरी प्रस्तुति में आ जाएं, वो भी एक वाक़ये से जुड़ा हुआ है। आज की आज शाम की अंतिम प्रस्तुति हजरत अमीर खुसरो की कालजयी सूफी रचना है, जो ईश्वर और आत्मा के मिलन, दिव्य प्रेम और पूर्व समर्पण का मधुर उत्सव है। इसे प्रस्तुत कर रही अवनी सिंह, अवनी राय, वंशिका टिकाड़े, त्वरिता जैन, राधिका ताम्रकार, भूमिका जौहरी, अन्वेषिता सिंह और सानवी श्रीवास्तव। यह कविता एक ऐसी अनुभूति को स्वर देती है जिसमें प्रेमी अपनी पहचान खोकर प्रीतम में विलीन हो जाता है। इस सूफी कथक प्रस्तुति में कथक की कोमलता और सूफी घूमर की रूहानी गति का संगम है। नृत्य की हर चाल, हर चक्र आत्मा की उस यात्रा को दर्शाता है जो मोह, भौतिकता और अहंकार को छोड़ परम प्रेम की ओर अग्रसर होती है। यह नृत्य केवल दृश्य नहीं, एक अनुभव है। वाकया कुछ यूं बताया जाता है। अमीर खुसरो साहब, जिनका मूल नाम अब्दुल हसन यमीनुद्दीन था, एक विलक्षण प्रतिभा के धनी थे, कवि, संगीतक और विचारक। लेकिन उनका जीवन बदल गया जब वे दिल्ली के हजरत निजामुद्दीन औलिया के संपर्क में आए और फिर उनके ही होकर रह गए। एक बार की बात है, अमीर खुसरो अपने गुरु हजरत निजामुद्दीन औलिया से मिलने के लिए अत्यंत व्याकुल थे। कई दिनों से उन्हें पीर की एक झलक भी नहीं मिली थी। उनका मन व्यग्र हो उठा था। वे दरगाह के बाहर बैठकर इंतजार करते रहे, पर उस्ताद बाहर नहीं आए। फिर एक दिन अचानक दरवाजा खुला, पीर निजामुद्दीन औलिया बाहर निकले। हजरत खुसरो की नज़र जैसे ही अपने आका पर पड़ी, वह क्षण उनके लिए समय से परे चला गया। उस दर्शन से इतने अभिभूत हुए, उनका होश, मैं, सब कुछ खो गया और आत्म विस्मृति की अवस्था में गुरु की छवि देखकर उनके होठों से स्वतः वह पंक्तियां फूट पड़ी। छाप तिलक सब छीनी रे, मुँह से नैना मिलाई के। अब मैं बुलाना चाहता हूँ इनकी संचालिका प्रसिद्ध नृत्यांगना क्षमा मालवी जी को, और सारे बच्चे आप लोग भी मंच पर आ जाइए। निवेदन है कि आपकी फैकल्टी आप लोग चाहें तो इनके साथ में एक फोटो बच्चों के साथ में, मैडम आप लोग प्लीज आ जाइए।
Once again, thank you Puruditya Academy for such a wonderful dance. It was such a mesmerizing performance. Once again, a big round of applause for them. So that was the end of today's program. I thank you one and all for being here and for being with patiently with us. So now we will move forward for dinner. Thank you one and all.
सुनील जी को, पूरे समूह को बहुत बहुत धन्यवाद। बहुत ही सुंदर प्रस्तुति आप सभी लोगों ने दी। इतने हैवी टेक्निकल डिस्कशंस के दिन के बाद में जो उसका अंत था वो बहुत ही मनोरंजक था और बहुत ही सुंदर था। आप सभी लोग डिनर के लिए आमंत्रित हैं। पूरी मैनेट और इसरो कोऑर्डिनेशन कमेटी की तरफ से आप सब लोगों को धन्यवाद। थैंक यू वेरी मच।